anyhow, so Robert has delegated out the task of being Robert. So I'm the pseudo Robert for the moment. This task, or this section, is basically a quick review of what Marko's been doing with that. We talked about this last year and various bits of work that's been done since then. Anyone here who has no idea what the network stack virtualization is? Everyone who, okay, no one's responded, so let's do a test. Who does know what it is? Who wants to see it? Who wants to make sure, who's here to make sure it doesn't get into the tree? Okay, so there's not a big fight about it at this stage, and it looks like something really useful. Marko's going to give you a quick rundown on just basically last year's slides, just a quick whiz through to get all the terminology in your minds. And then we'll look at, come back and look, I think we'll put slide number 2, we'll come back to that one, and just look at the way in which he has added the ability to virtualize modules. And we'll look at maybe how we can extend that to other modules for virtualization, whether this can be hooked in with more jailish sort of behavior for virtualization of other components in the system. And then we'll probably go to just comments and talk. So I'll just step out of the way and let Marko do his thing.
Okay, thanks. So the basic idea I've been playing for the past 5 years was... Can you hear me, guys?
Not really. Not when you turn and face the slide.
So, yeah, it should work, this one.
It works.
So, the idea is to extend the existing network stack to allow multiple instances of independent states to be maintained in the kernel, so that we can have something like enhanced jails. Let's start thinking from that perspective. So I've been hiking this for the past 2 years, sponsored by FreeBSD Foundation. Sometimes doing less, sometimes doing more. What we have now are 2 major branches that are attempting to track FreeBSD current and FreeBSD 7 stable that are maintaining perforce. Those 2 branches are slightly, I think, lagging 2 months behind the CBS. I've noticed that Brooks has treated, so you can tell us.
Yeah, well, what I did is one of the things with the current strategy of if-defing the code to be able to compile it in and out made it very hard for me to read. So I basically went and ran unif-def on it and said, okay, so assume we committed it and removed all ability to make it optional. This is what the code would look like, and I found that much easier to read. And we could talk about some things that could make it easier to keep that if-def in, but still make it easier to read.
Okay.
I've got some ideas there.
How much code was behind the if-defs?
I don't remember offhand. It touches quite a lot of files. Several hundred, right?
It touches the entire
Right, not how many places, but how much code it.
So
anyway,
a diff should be a megabyte or so, at least, and growing.
Several thousand lines removed finally.
So the growing issue with breaking this in separate trees is that the amount of time that goes away just for synchronizing with the other changes becomes, well, frustrating, and especially now that there are 2 separate trees to break. So, well, it used to be fun. It is still fun for me, but well, the syncing part is not fun. So the sooner we move to the next step, the better for me, and I hope for everybody who's interested in seeing this. Okay. So I think we are not in a much better position now Okay, last year we didn't have IPsec visualized at this point in time. INET 6, I'm not sure if it was.
It was partly done. It was partly done last year, I think.
Okay, so those three should be like really working. The conditional compilation, okay, the idea behind the changes are that they should be revertible back to the original kernel, so that if we screw something while having the kernel configured for having multiple network stacks, that shouldn't necessarily break the code that we now have in the CVS. So by using some macro mumbo-jumbo game, the code can revert back to, well, say 99% of what we now have in CVS. The 1% of the changes that cannot be made really conditional are related to the sequences of initialization of various subsystems. Okay, and that relates also to the way how the well, KLD modules are handled, because really here the issue is how to attach some subsystems to several, well, tens or hundreds instances of network stacks at runtime. So okay, we'll see later what the problems there are. But generally, the biggest issues are ordering, enforcing proper ordering and dependencies of which subsystems should be initialized in which sequence, and what has never been done in the original network stack, in which sequence they should be rolled back and released once an admin decides to destroy an instance of network stack. So this is perhaps the most challenging part of the implementation, and still has quite a few issues. But again, this should not be this part should not be endangering the normal functioning of the normal kernel. I hope I haven't done too much damage to SMP. So far on the normal data paths from the interfaces to the sockets and vice versa, the changes that are in Perforce have not introduced a single additional block. So, well, where additional locks have had to be introduced are in places which are executed periodically, like TCP timers or, well, dominant timers. In those places we have to iterate through all the existing, through all the instantiated stacks, so, well, locks are needed there, but let's hope that those the frequency of such events is reasonably low. So the TCP timers we have them executing like a couple of times per second. For dominate, it's a little bit more difficult story, but then again, it's not anything. It shouldn't be anything exceeding 1,000 lock acquisitions and releases per second, roughly. Okay. What I succeeded at, spending money but not finishing the project. Thanks a lot to and FreeBSD Foundation. And well, I'm also successfully lagging behind. So let's look what's where I didn't succeed. So what's lagging now is management interface rewrite. So the original implementation that I did in 2002 and 2003 got some pretty hackish management interface that I kept to these days. the change that has been recently introduced might be quite interesting to some, but well, to other guys not so. The framework allows a hierarchical organization of virtualized environments. So we could have a virtual, it's not a machine, it's a virtual environment owning several children and so on. So we can have parallel branches of in a hierarchy being fully protected from each other and independent. So this might be useful for some like grouping categories of users environments. Anyhow, it's there, but in general, the management interface needs to be rewritten from scratch. So the real question is, what do we want from such an interface? So should we just focus on networking, or think more broadly how to manage and deal with potentially broad range of system resources that we might wish to virtualize? Okay, so definitely there's more work to be done, and well, I'll be busy cleaning this up in the next month too. So any questions so far? So basically, I think I'm done. Well, with my ex-cathedra talk. So what I would like to have is this debate. I don't know how many people have looked at this code, and what I have tried to push through in this recent clean slate rewrite. I tried to introduce additional layer of indirection, which would make networking only one of the potential resources to be virtualized. So a few months ago, I had a functional virtualization of system load accounting, I think, which got slightly broken by recent changes to more adding more parallelism in the scheduler. But this serves as its purpose to show that the framework can be used for not only visualizing the network space. So. Well, I prefer to have questions, debates, than just telling you the details, who points to whom, who owns what.
Question?
Okay.
Why would I not want this in my kernel?
Sorry?
Why would I not want this in my kernel?
So potentially one issue would be performance. I did only lousy performance measurements, and I think from the last year, comparing TCP throughput over a loopback interface on this laptop on a unit processor couldn't yield any noticeable difference.
You can't really see on the screen. I think there's supposed to be 2 lines on the graph.
Yeah, there are, but they're on top of each other.
So they're roughly.
That's the whole point.
Oh, the point is that there's only 1 line.
But I think that there should be some difference. I think the issue is that our loopback, our TCP throughput through a loopback sucked at that time. I don't know if that's still true. But anyhow, this can serve as an indicator that we shouldn't worry that much.
Yeah. Certainly, if we put the code in now in its form where it can be turned on and off, we should be able to do a lot of testing by just simply compiling it one way and then compiling it the other way.
Right. My concern is from 2 points of view. One, an tiny embedded application. We heard earlier today, and I know Paul Hennings said on other times, we can't make the kernel small enough. We keep putting in pieces that are not optional. Two,
But that's why this is optional.
well, but I'm hearing some kvetching that maybe we wouldn't make it optional and unif-def it or figure out. So that's why I was asking just how much code. And,
I mean, the memory overhead of only having one instantiated is next to nothing. It's a few extra pointers.
but even in,
You're simply consolidating global variables.
right. So also, but from a storage point of view, when you start getting embedded, it's several things: memory footprint while running and storage footprint. So that's just what I was asking: how big, how much code.
Yeah, well, I mean,
some global variables around.
you're moving a
Well,
bunch
no,
of variables
that's what I
from.
was asking.
Yeah.
Just tell me
Yeah.
what it is. I'm not
Basically,
arguing.
what you have is a bunch of global variables, and you're just putting them into a structure and having one structure, so they're just all in one place. So it moves from being in the BSS for initialized data to uninitialized data.
Which is even better for a storage point of view.
Well, from a storage point of view, yeah, you might even gain
Right.
a block.
If your alignment's just right.
So, so you seem to
So
be
the
implying
embedded
that
stuff is really
you might want to see this combined with jail stuff somehow, or maybe the management tools for jail or something. What are your
Yes.
ideas there?
Yes, yes. So well, it's not my call. I think we shouldn't just depreciate jails. In fact, in this prototype, it's possible to run multiple jails inside each virtual network stack instance. But definitely, we should think about unifying the management units. For example, it might make sense to have freely combinable, like CPU scheduler constraints or priorities with this or not, depending what you are trying to do. So, and not have like. So we probably shouldn't be thinking about those guys here like virtual machines, but to reserve some freedom which subsystem to enforce virtualization on or resource limiting on which not.
There's a wiki page about some virtualizations.
Okay.
Who's in that?
Have you thought about binding,
Because he's not here.
basically virtualized instances, actually binding them to jails so that we can remove some of the corrupt that jails have left within the network code?
I haven't been thinking about getting rid of jails at any point.
No, not getting rid of jails, but actually binding one of these virtualized network stacks to the jail and then having the jail use that stack for all of its network communications.
That's what happens at the moment.
Yeah, that's what happens now. So
Oh,
basically,
okay.
this code reuses a lot of jail code for separating processes running in one environment versus the other environment. So on the user space, it's basically just jail code with looking at another, having another comparison whether this process can mangle the other one, and that's it. So.
How is loopback handled?
So
Each one of these stacks?
each one has an independent loopback interface instance, which is created by default when an instance of those is created. So normally when system starts up, automatically default instance is created, and it's impossible to make a distinction between plain kernel and the modified kernel. And unmodified applications run on top of this without any major problems. So one problem that, one of many problems, perhaps not the most pressing, but one that needs to be solved is the usage of KLDC interface, because if we want to enforce security in those environments, we shouldn't be allowing direct read access to the KMM, and without this we cannot read routing tables at the moment. So for what I'm doing with this framework, this is emulating network topologies. I don't care about paranoid security that much, but if anybody wishes to push this into production, then opening the KMM to potentially untrusted users isn't the best idea.
I'm actually considering changing netstat as the example you've got up there.
Yes, yeah, I think that's the most blatant.
In the probably the most egregious user of this at the moment is netstat. When you do a netstat minus R, it's looking inside the kernel memory and getting the routing table and decoding it itself and printing it out. There really needs to be some more official API for that. And now that I've added multiple routing tables, in fact, the version of netstat at the moment, I was very, it has to be, the one I've committed at the moment is backwards compatible, so I've kept that. But my next step is probably going to be to write an official API to get the routing information out of the kernel in some other way. And when, well, yes, though routing tables can be pretty damn big. Yeah.
Do we really use?
Hmm?
So you're saying it's a lib KVM consumer?
Lots of
today?
things still use libkvm. We've gradually been eliminating them, but
I know, but
netstat
I
is
thought
one of the
netstat actually
some
was
things
enforced.
netstat does syscontrol. So netstat connectionless using syscontrol.
But the routing tables still use libkvm, and
some
that
other
was,
random
that was a
stuff too.
problem for me when I did the multiple routing tables, and it's going to be a problem for Marko, and it's something that I was thinking of fixing. So if I fix that, then it'll go away from his list,
Well,
and reduced by one.
The other thing you could do is on the interfaces that you know are risky, you could check if you're in one of these virtual environments as they're being called and just decline or something like that. If you really had to deploy something like this into a production environment where you didn't trust your users.
But it's not a matter of trust, it's just a matter of it's an ugly interface.
Right.
Yeah, everybody needs that stuff. I mean,
Yeah, sure.
and you cannot check for each call whether the
No, you
exact
can
memory
check.
location should be allowed to be.
You can check for opening devkmap or something like that. And just
Well, yeah, well, that would just allow access to the whole thing, and I think that's what we do now is we exclude devkmap from the jails.
Yeah.
Yes,
Because
that's
it's
right.
working in kernel memory directly, you can't
Right.
restrict from what it does other than disable its entire access.
Yes.
What's the PF? Probably.
PF is packet filter imported from OpenBSD, I believe. So I did virtualize it last year, and then a new version got imported. I think it took me 3 weeks to virtualize it in the first place. So now it's not virtualized anymore. So I just didn't have nerves to spend 3 weeks. Well, if this will go into CVS, then it's another story. But I can virtualize it, and then in months it can get a new version imported. The changes are so huge there that it cannot be incrementally updated. It has to be done from scratch.
I think this is the main issue here. What is the impact, the future impact on any work on the network stack? So what does it mean for kernel developers, for code importing, and this kind of things?
In the current code with the macros, it's actually less than it would be without the macros. It's easier to read it without the macros, but with the macros, the changes become a lot smaller because you basically, in a lot of places, you're just replacing some variable name with the same variable name with a capital V in the front of it.
Yeah. So basically, okay.
So maybe actually looking at a diff of a subsystem might be useful.
Okay. So okay, basically, okay.
Well, you don't need that actually. You just scan for VMage in a file. That's part of the problem in my view. Is it would be much easier to read if we always did the consolidation and just created a static instance in the non-VMage case.
That would be true, but that would be a nice thing to do. The question is whether or not we're willing to take that hit as a separate commit ahead of time.
I think it'd be a reasonable iterative commit. It shouldn't, and that's very easy to verify.
Yeah.
It's kind of explored.
So we could do that as a prior step.
Okay.
Yeah.
Oh, sorry. Okay, so we need to include.
Can you shift the window very slightly to the right?
Oh, sure.
Losing the left column a little. Thanks.
Can everybody read this? Should I increase the size of the letters?
Okay.
It's okay for us.
Okay.
Then about people look back.
Okay, so, well, depending on what's written here, then we have clean or macros resolving to this or that.
So Marko, I was thinking for you can. If you go through that, I'll say what they are, and you can tell me when I'm wrong. Now we will see whether I really understand it.
Okay.
Okay, so the first option there, we're obviously just declaring we're going to be doing this or not. So it's just inclusion of the option. The second one is some includes for the various macros and so on which are needed for it. The next one down, no, up above that, VNET.h.
Okay.
VNET.h is the include file for the specific sub module that we're virtualizing. In this case, it's the networking code that we're virtualizing. So that has stuff that's specific to the virtualized network stack. And I guess the next one, VINET, would be specific just to INET. Is that right?
So in VNET we have protocol agnostic stuff like interface lists, routing table heads, and that's it.
Do we need to have those going forward?
So can we combine that code in some existing headers?
Oh, no.
Well, because it's data structure declarations, the wrapper structures.
So those guys might need recursively include. So the INET might need including some INET specific headers because in this.
But in the future, it could move into in.h.
Right.
Yeah.
Okay, and VNET.h could move theoretically into, say, well, it would be, I don't know, it would be route.h and if.h. Those two could probably go away. Okay, so the next set of thing after the conditional include, these are all the variables which were in here. Sorry, yes, no?
Okay.
Not defined yet. This is the old global variable.
No, they've been plussed. I don't know.
If I can interfere here,
Yeah.
I think those variables have been I don't know what's the proper term, given initial values at the declaration. So since we'll be doing assigning initial values to multiple instances of the same thing, then it doesn't make sense at all to have,
Initial values in static.
initial values there, but we have to assign initial values in initialization procedure for each stack instance that we wish to instantiate. So probably we will see a little bit down there,
you can see
the
it
lines
forwarding
with-
right there.
You can see arrays of those things.
Okay, IP forwarding, okay, assign 0. So here are those guys just grouped without the initial values assigned. You wish to go on?
Sure.
Yes.
Okay.
Okay. So then we're changing the syscontrol to be a new kind of syscontrol, which is the virtualized syscontrol. I don't know the details of how you did this, but this is where you can do a syscontrol to affect just the value in the jail, or in, I was going to say jail, in the virtual machine which you're currently existing. Is that right?
Yeah. And of course, it falls back to the standard syscontrol if we are compiling no options Vimage kernel.
Can you reference somehow those variables of other virtual machines?
You have to be inside. You have to switch into the context of the other virtual machine, and then we can mangle those syscontrols.
Well, this isn't a true virtual machine, right? Perhaps will confuse everyone. Virtualization though. Yeah.
We've got to think of a good name for these things.
I mean, so far it's just a virtualized network stack.
But it includes a virtual like jail as well. I mean, you've got a separate
Right.
file system, separate. You can't see processes which are in the other ones. So it's basically a superset of jail
Is that actually there?
Yeah, it didn't.
Yeah. because it uses the jail code to do it. It's actually hooked on top of jail. So
When it comes
that
to
anything you have in jail, you have in this.
virtual stack only, it's not a problem, but when you connect it with
Well,
security
that's
like
what he wants
jails,
to talk about.
we had already such fall, right? When you change the context into the jail to change something, which isn't safe. And this is basically what I'm asking for. Is there a way to change some variables of some virtual machine?
Well, you want a synthetic tree hierarchy that's visible outside of any specific VM that is one virtual tree hierarchy for each VM.
For sys,
Yeah,
for sys
So yeah, you want to
Same way it works for the file system.
syscontrol jail number 2 dot
yeah.
net dot
But
IP
sys
dot
controls, I think
maybe.
it's easy.
Yeah, I think so. You can just follow the namespace.
But, stuff like
It's sys5ipc is the hard one.
So
Silly stuff.
are you at all familiar with Solaris containers?
only by name.
Zones.
By name and description, but I have never seen one
Okay,
live.
so it's our jails on super steroids where you're.
What the super steroids mean exactly?
So you look like you're booting a kernel. You can reboot your jail. It gets assigned. They virtualize the network stack, kind of like you've shown here, to attach to each container. You can also do CPU scheduling. This container will get at least 50% of the CPU. This one could have no more than 25% of the CPU. Memory, allocation policy, etc.
It's like a proper virtual machine, except you have to run the same OS.
Oh, well, I'm trying to say we're away from virtual machine because it
No,
makes too many
in terms
things
of
too many
facilities
people.
it provides.
Well, it's not.
You
It's,
virtualize the kernel.
it's not as
instead of
clean
the-
as you're
instead
saying.
of the machine.
it's not as clean as you're saying.
No, I'm saying. No, so I'm
There
trying to
is
understand
zones are jails on steroids, but zones are not true virtualization of all the kernel data structures, and they're not as virtualized as is being described here in the case of the network stack.
You may disagree that they're not as virtualized, but I'm asking, are we headed towards that?
Yes.
Are you
Yes.
saying
I think
the
so.
framework that will take
Right.
us there?
Yes.
But it's not all there right
Yes.
So
Correct.
as a digression, Linux folks have also a thing called OpenVZ, which is maintained in a parallel tree by some Russian guys, which
Actually, a lot of that code's getting into the mainstream kernel.
So it would
but
be,
not the network stack
Yeah, not the network
virtualization.
stack.
But I mean,
Their namespace, for example, the UID namespace and all that is now in Linux tree.
so it would be nice, I mean, virtual machine to me, and maybe from working at a hardware vendor, is virtualizing the actual hardware that's the
Yeah,
machine.
well-
This is more virtualizing the
But
kernel.
we haven't got a good name for it.
Well, that's what I'm saying.
Well,
It would be nice if we
The
could
name
do
people
more.
were pushing was vimage, right?
Vimage isn't a good name for it, sounds like.
Vimage sounds good to me.
Virtual image.
Okay.
It depends on,
Varial's version of this is called Feature.
that's actually kind of, probably more true to what you're doing.
Just as a pre-announcement, we got approval to actually contribute a lot of the stuff back.
In my talk on Saturday, I'm going to be talking about some of the resource limiting we do and the techniques we use to do it and why you want to do it and things like that. But we hope to. Well, I don't know what state this will be in by the time we get permission from our lawyers and all of that. But
Which we are you?
very good. I'm very.
You're the same we as that we.
Yeah.
Okay.
Both of us. So
We're surrounded.
Sorry. Anyway, we're going to be contributing back a lot of our resource limiting code and merging in. We've been keeping ahead of jail as it progresses with our own virtualization technology since previously 3.2 or 3.4.
Yeah, 3 something.
Anyway, and anyway, if jails had existed, we probably would have just implemented them then. But we're planning on now merging our stuff back in, most of it anyway, not all of it, but most of it back in with whatever the current virtualization stuff, which looks like maybe Vimage is the way to go.
So the question arises, what is the framework that we could contribute virtualization back into? Is it jails? Is it Vimage? Will both exist? That kind of troubles me. Are we going to have 2 virtualization frameworks where there was just one before?
Or hey, we have our own too, and we can have that.
Yeah, we can make 3.
Right now you can have jails within.
Well, I think what it comes down to is that at the moment, the virtual image stuff uses jails.
Yeah.
So for those things which Jails doesn't handle, it handles on its own, and for those things that Jails does handle, it allows the current jail code to handle it. And then on top of that, you could have the jail code on its own as well. So you could have basically a jail that coincides with the virtual image, and thus you have like a jailed virtual image, right? But you could have another jail inside that with running on the same network stack.
Do we need that going forward?
Yeah, with being hierarchical, if you could have hierarchical system of jails that may or may not have the networking stuff in virtual image or may not have other features, then wouldn't just jails suffice, or whatever we would call them then? Just jails, just vMages, just one framework that could have different features turned on or off.
Yeah, well, I think that's what we want to get to.
Yes.
Yeah. So you basically have a virtual image and you turn on and off some stuff.
Yeah. And some of that stuff is what the old jails would just be one of the, or some of the features you can turn on or off in a virtual image.
Yeah. The question is, what is the framework that we're going to hook this stuff on? And the macros that he's doing at the moment implement the structures that were on the page before, which I don't know if you can.
So the hope is that framework, those macros subsume jail, swallow up jail rather than coexisting.
So what happens here is every module, where a module can be considered to be a kernel, loadable kernel module equivalent, basically all the global variables that were in that loadable kernel module moved into a structure, and then that structure is that structure is hung on a. I'm going to draw this better than I can talk it. When you load a kernel module, you basically allocate a slot number to that kernel module. So let's imagine we have. Correct me if I'm wrong. But let's imagine we have.
Why don't you do it over here with the capture program?
Yeah.
Threw a tiger behind there.
That's the jail. That's.
Please draw Julian behind these bars.
Of course, the next question is then.
So when you allocate when you load a kernel module which has virtualized components, this is listed where we're going. You say, okay, your kernel module number 4, okay, which means that for every virtual machine, and there's another virtual machine here, you set various slots. Every vimage, you say, okay, the fourth one of these, 1, 2, 3, 4, the fourth one of these points to the structure with all the variables for that particular module, and the fourth one of here points to its version of that structure with all the modules. And then you load another kernel module and you say, okay, your kernel module number 5
is firewall, say. Say to be a firewall.
Yeah,
so we have a system without firewall, then you
load the firewall module and say that your kernel module number 5. So it points to this, and this is where it puts its stuff here.
So this is from the code. If I were to load firewall modules, say IP or PF were working, then all of the virtual images would get PF?
Yes.
Okay. Yeah, well, that's the.
And you load. You could possibly decide not to, but that would be a different part of it. That would be an extension to the ABI.
Right. I would have to do more work on that. That would be hard.
Well, but I think it's critical that we be able to not enable the feature in a particular vimage.
Yes, I agree.
If it's going to be of any use, I mean,
okay,
because
but the point is, it's just a link. I mean, if you just don't put it there, then it's not there.
Yeah.
So yeah, you just need some management tools.
Yeah.
But on top of that, can I have 2 firewalls? Can you start to load modules within the vimage?
No.
There's one kernel.
But you could, however,
but if you've got the
You can load it, but it only touches on one vimage.
right. You could load PF and IPFW, and you could expose PF in some images, IPFW in some others, and maybe both in some.
You have a single instance of code, but working on multiple instances of data. That's it.
Right.
You cannot have multiple instances of same code.
Different PFs, different versions of PF for different.
If they register themselves as a different module, and what
All the names are different.
Such an option has nothing to do with what we are trying to accomplish. I mean, if you could do this with the kernel from CVS, well, you would be lucky guy.
No, I mean in the future.
But you could say one jail user wants PF, the other guy really loves IPFW. You could load them both, expose them to which guy wants which, it looks like.
You could theoretically, if you had the API to do it, or other than, you know, which we don't have, but it becomes a possibility.
Right.
So anyway, does everyone understand how this works? So when you load kernel module number, so the code for this kernel module, which we loaded here, has a global variable. This is a true global variable in it this is the IAM number 4, okay? And the code for this that we loaded here and went to here had an actual variable in it, which is IAM now number 5. So all of the code in this module knows that it's the 5th one in this list of things, and all the code in this one knows it's the 4th one in this list. So that's how it does the indirection.
Okay, so, and this number is the index to the mode data array, which tells us, yeah, okay.
So if you go back to your diff, it'd be...
So these are basically loadable kernel module equivalents. Okay, in case it might be a bit more than that. Sometimes it looks like, for example, I think there might be modules which are more than one loaded kernel module, maybe. I don't know.
Say again?
Would we have modules where we would have more than one kernel module? No, probably not. Sorry.
Modules where...
Don't worry.
Okay.
So can we go back to the diff? Not necessarily have to go line by line, but show a little more flavor, just very briefly what the changes look like. I mean, I think we can read the diff pretty quick, just
Okay,
space bar.
so we have syscontrol virtualization. Okay, here's another guy that had initial value, so okay, this is a lot of syscontrols. Okay, so then this guy here exists in global namespace only if we are compiling the plain kernel. If not, this guy will be in VNET.h embedded in structure. In structure, which we see...
Well, the system controller defined is below your removal of the definitions for IP reassembly.
Sorry?
The system control redefinition is below that if that block. Keep going. Down. It's there. That's the redef for the virtualizer.
That's the redefinition of the syscontrol.
Yeah, for the virtualizer.
For access to that structure.
Yeah.
Okay.
Now,
skip the syscontrols and go down to one of the functions.
Well, hold on. The pound defines this here taking out.
No, it's because diff sucks.
I'm sorry?
It's because diff sucks.
Okay.
So go find a function.
Yeah, go find a function.
Okay, so
this is the initializer routine, so this is a big difference.
This is a good one.
This is the most.
This is the equivalent. This is the equivalent of those static assigns that you saw for the global variables. This is adding values to the actual structure where previously they were static variables that were assigned statically.
So okay, so the key question here is that for different initialization functions, we are using different initialization frameworks. We use sysinit, we use protoswitch. Wow, help me. There are many more, definitely.
Timetable.
Yeah. So essentially, what I am doing here, replacing all those quite random and diverse methods and concepts with a single unified method is, well, I haven't thought about anything as general. So what I'm essentially doing is recording the sequence in which all those subsystems are trying to initialize something that is virtualized. And then I try to replay that particular sequence later when somebody explicitly requests instantiation of further virtual network states. Okay? This is dirty, but this is how it works, and so far it seems to be pretty much working okay into the opposite direction. So we have to clean up these structures in exactly the opposite order as they were initialized. Okay? So that's the best I have thought of so far. I'm open, I'm all ears for alternative proposals. Okay.
Now that you have the image stacking, I was expecting to see something like parent vimage and current vimage. When you create a new vimage, right? You always have parent. You have you have the image which you start with, right?
Yes, yes.
So you always have parent vimage, and for example, when you change some global variables inside this vimage, and you create a new one as a child for this vimage,
Okay.
it should inherit all the variables, right?
Yeah, that's a reasonable option.
It's not done.
It's a
It's
reasonable
not
option,
done.
but it takes time.
Yeah. As you can see, it.
For
It's
example,
not,
when I turn on the forwarding in my parent vimage,
we could do this. We could do this. It's not done. So they're entirely independent.
We will reserve that piece of work for him.
So, but I think those should be more or less like cosmetic issues. If but don't get me wrong. So I don't see this like something that would be extremely difficult to implement. It would just need time. But getting the proper ordering and having the dependencies between modules done right, this is, I think, the well, choking point of this
basically,
whole
when
stuff.
you create a new instance of vimage, each subsystem is called to initialize its own data structures, right?
Yes, 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 yes. And it must be done in, well, proper order.
The same order in which the sysadmins are done in the system boot up.
So when the system boots up, you have sys in it, then you have domain in it, then you have something from routing table in it, then you have another sys in it, then you have some probably proto switch, something does something, then you KLD load some module, then it does. So and you can have things initialized in a pretty different order depending whether you have compiled something statically or have you have you loaded your KLD module via the loader, or the third option would be KLD loading kernel module at runtime. And you get three completely different sequences, and they all must work. So far for
Because we're adding a fourth possibility, which is KLD loaded at some time, and then you create a new vimage an hour later. So that's a completely fourth order.
So again, I want to emphasize that I see this ordering and dependency handling personally as the critical point that I'm not sure that it is done right, but it doesn't prevent this from functioning as a prototype. So
if I look at the first two lines of that function, you just change the variable name in, if header, if header, down, those two. You simply change to prefix d underscore.
D underscore is magic.
Okay, there is magic behind it.
There's a macro.
So this results back to the original global variable if we are compiled with no options image.
Meaning it's not a gratuitous change, we need to live with the change.
So that change basically says, what that change says is basically get.
Well, you can
It basically makes it follow this link to the variable. Okay, you get to the variable.
Fair enough.
Okay, so again,
And the first line, the init VNET, init current VNET, is basically initializing a local variable at that point, which is hidden, the name of which is hidden from you, to the value of current VNET, which is in the thread at this stage.
it's not setting the init to car VNet. It is Okay.
It is the warrant.
It's the current VNET.
Current VNET.
But focus on that for a second.
Just to explain this previous, so it was init, VNET, init, so it creates VNET, init, which is pointer to, well, this guy in the middle, from a pointer to the VNET. So VNET is, this guy is VNET, this guy is VNET, INET, VNET, INET 6, VNET, IPFW. So just simply VNET is the...
It's following some of this.
Yes.
So it's caching basically a pointer here, or not here.
Yeah. From pointer of this is
Comes a pointer to that.
yes.
So you don't have to look it up every time you access the variable.
So everything you've got there is VNet underscore something. If this is still the framework for not only network, but scheduler policy per
We have the
virtual image and all.
we can look at the different stuff.
Okay, but so that would be INET,
It would
V
be-
schedule.
It would
I'm
be
not sure if you
for-
want to combine all those things in the image actually, because if the overhead is significant to initialize each V image, you might end up with a situation when you really want to have many jails sharing the same V image and the same CPU set and the same resource limits and stuff like that.
This is why I think it's really important to have the hierarchical support and to have the ability to create a VMage that is only, say, CPU limits.
Yes.
And that should be cheap. If it's not cheap, the system will never work. And I would assume that it is cheap because it should be just settings and variables.
Right, that you pass to the scheduler, and there's what your quorum now is.
So I think that hierarchy is very important.
So just to make just to add a working example of why you might do that. Suppose you want to have a series of essentially virtual images that represent complete network stacks and everything else on your machine. And then inside of that, you want to use our current jail facility that just does sort of very weedy little things, right? A little bit of process protection to protect you from named and a couple of other specific services. We don't want to lose the ability to have the very lightweight jailing we have today when we gain this stuff. So having a nice spectrum there is actually
I would
quite
like
practical.
to see the key pieces out of jail pulled out and made into VMage.
Right, oh right, absolutely.
This is feeling like two very different.
Can I show you something?
What's the end goal?
If we imagine that this jail, or this VMage, whatever you want to call that thing, is inherited, is a child of this one, and we decide that we didn't want to inherit this particular module, we didn't want to get a new version of it. You have two options: either we don't allow that thing to exist at all, like it's going to be literally this is a null, so we don't have that option available. Or the other option would be that we simply add a reference count to this one here, and we make it go down to here. So what's happened here is that we have inherited the same data structures as the parent that we come from. So consequently, we're going to have the same, whatever that is, as the parent does. So if this is the network stack for IP version 6, okay, then this child jail, or virtual image or whatever, is going to have the same network world
This is
as
the
this.
problem.
This
one of those jails can modify the structure, affecting the other one.
But that's what you want.
No.
If that's what you want.
Yes.
Yeah. It could be what
If
you
you've
want to
done
do.
this, then that's what you've asked it to do. Okay? If you haven't asked it, if you want a separate one, then it's not going to be able to. If you have explicitly said inherit this from your parent, then that's what you've explicitly asked it to do. So you could inherit CPU scheduling functions or accounting functions from the parent, so that the child jail / images, whatever we call them, would inherit that from the parent. Then that's what you want to do. So it's not a security problem. That's
For
a feature.
example, now jail cannot remove IP address from the interface, right? You can do that.
Yes.
Affecting other ways.
If that's what you want to do.
Currently, you also share IP address for network interfaces between jails. And then you cannot.
No, you can't. You don't share interfaces between jails. No, you don't. In jails, in the standard jail, if you want two jails to come from the same net, you will bring them into a virtual bridge, and you bridge the two interfaces, and they have their own interface addresses.
Theory, create many jails with the same idea.
Subsystem argument to the variable.
Like with jails, you can have
That's right. So V underscore N, as you said, right, should depend on whether or not you're using a virtualized.
They can add their own information if they want to.
Well, you're in the init routine, but elsewhere in code, it's not going to be huge because you might not have virtualized.
So it seems like I don't know what your name here is. This thingy. This gentleman was pointing out that what all of this discussion is about is we don't have a clear idea of what the management API for this would look like. And once we do, well, the rest of it's just how are we going to fit the pieces together? Because it looks like we have a lot of pieces that we can fit together.
And we have a framework that we can do it.
And we have a framework to do it, and we just need a good management API that makes sense. Something lots better than what we currently have in jail.
Well, or you just keep calling it jail, and this is the new way to implement it. I mean, is that
Jail's the trade name is what people know FreeBSD has for virtualization.
exactly? I mean, that's the other thing.
I think that's a good idea. So we'll treat jails, new jails, and we just call them,
We have new jails.
But you have to be careful here because it's not the same thing actually. So we have to differentiate between the use cases. So currently jail is a system where you can sort of create on a dedicated IP address something where people can run their web server in and that kind of stuff, but in a controlled and sort of limited environment. They can't change the IP address and so on. So you've got some control over that. With the Vimage, they've got sort of like a complete virtual machine in the network kind of sense. So they can do if configs, different IP address, and so on.
But
you would have to bridge.
Well, we could limit that somehow.
That's what Solaris does. Is when I get a
if
container,
you wanted.
when I get a container, the global zone admin has already said, I took away your IF config ability.
Right.
You run it, and
You get read-only IF config.
or it's like a user instead of root. You know?
That's currently not the case with Vimage.
No, but it could be. We're just talking about where to go.
Those are
attributes.
Well, what's
We have those.
capabilities, what
We
can
have
be?
the conditionals are in the code to do that for jail at the moment. If we just leave the conditionals in there.
Right. Well,
Just hang them off of there as a set of attributes that you index.
So when you want to create one of these new images, going back to the API, the management API thing, what are the arguments to creating a new V image? What are the properties that you request when you say give me a V image as a process?
At the moment, I just request a new one.
Right, and so it's the same as jail. Jail is give me a new jail, right?
So-
but jail is also here's the new to root. Right?
So it might be that you want the API to say, give me a new one, and then you assign attributes to it. Oh, I want this one to have a network stack. I want this one to have CPU shaping. I want this one to, and then you get another one that you only assign change root to.
Right. Well, but do you anticipate? But changing the properties of things rather than doing it in initiation time, comes with overheads, right? But do you anticipate a usage case where, for right now, a vimage doesn't have its own network stack, and then a few days later you decide maybe it would be better off if it did have its own network stack? I have trouble kind of imagining a usage case for that one.
Yeah, no, I think that you'd come up with templates or something ahead of time.
Right. Well, that's what I'm kind of thinking is, when do we create these images? Well, we create them when a new virtualization customer turns up at your ISP, or you create it when you deploy a new service onto your server, right? But these are they get set up when the system boots up, and you get like 10 of them that you configured previously. But it's not, you're not saying today I have a vimage that has support for System 5 IPC, and tomorrow I decide that it doesn't get System 5 IPC anymore.
No, but you might say today I have a vimage that has a certain amount set aside in kernel memory for System 5 IPC, and tomorrow I want to change that amount.
But it is.
Actually, your consumption.
So you either change it on the fly or shut it down.
They shut it down, they change the value.
Yes.
So basically, subsystem and subsystem value tuning.
It'd have to be, if we're going to go with a modules thing like that, I mean, it's going to have to be, a per system, this system, and then I set these values in.
Well, right. So what I'm wondering is, does the call to create a new vimage essentially accept a list of subsystems that will now be more virtualized than they were before?
I would think so, yes.
To be flexible.
Right. So I'm creating a new jail. Right. I'm creating a new jail. A new vimage, or whatever I want to call it, right? And it's going to have a new IP stack. And so I'm going to set a set of flags, or I'm going to provide a list of things that are now virtualized.
Yeah, a list, kind of like a mount.
Right. But do we want to offer the option to not have access to certain facilities? Like one of the things that you do right now with jail, and largely because the virtualization is incomplete, is deny access for System 5 IPC. And so we have an administrative problem that says System 5 IPC might not be available at all inside this jail. Do we anticipate wanting to have that kind of facility for VNET?
Right. It might be that if you want to take the paranoid security view, you'd say nothing works unless you enable it, and then you have a big list of things you turn on or some wildcarding or something. Or you could go the opposite route and say normally everything is on unless you explicitly disable things or wildcard disable things. So, I mean, it can work either way.
Yeah, well, I'm just wondering what we want it to do.
I go for the paranoid view myself.
We should just make a clear distinction between virtualizing resources, which really means that we instantiate, we reserve spare amounts of memory for some purpose, and the capabilities, which really tells us, okay, we give this guy this perhaps list of interfaces, but he cannot configure it. We'll be perhaps configuring this for him, and then set the bit or something like this. And then he has an environment where he cannot change his IP address, MAC address in particular. So capabilities and resources.
Well, that's what I'm wondering. So I'm wondering, so there's this system call which says give me a new vimage. The arguments might include then, suppose things are either virtualized, either they're newly virtualized or they borrow the one from the parent. So maybe it's a long bit mask, right? For this subsystem, okay, we'll virtualize it. For this subsystem, well, we won't virtualize it anymore. Or a comma delimited list of subsystems by name, right? Right. Okay, but that's a three-way mode, though, right? Because
I can think of the three options that we would.
Are there any other options that we're interested in, other than this subsystem is not available, this subsystem is shared with the instance that was in the parent, this subsystem is a new instance that is not shared with the parent?
Well, back to the net stat, that's not a subsystem per se. I think there's just a set of attributes that you can start utilizing throughout the system.
Okay, so there's a concept, there are two kinds of privilege in a FreeBSD system right now.
Right.
There are privileges that have to do with violating access control policies or overriding access control policies, like the ability to override file system permissions.
Right.
And then there are system management privileges, which give you special privileges with respect to how the system operates, such as the ability to access kernel memory and do things that really violate integrity constraints of the system. So the latter category are typically things that we simply turn off in jail, right? Because they would violate the constraints and the virtualization of the jail environment. So we don't allow you access to kernel memory.
We don't kind of say, I've more virtualized your area.
Right. We don't virtualize kernel memory, for example. Right. Okay. But the former category, which is administrative rights that would not violate the integrity constraints of the system, we started to make into flags on jails, right? There are a number of flags now. You can do this in jail, you can do that in jail. As I see it, when it comes to the integrity constraints, you want the integrity constraints to be a subset in the jail, not necessarily a strict subset, they could be the same set as the parents have, because you don't want any child image to have more rights with respect to system integrity than the parent had. But the other rights, like the ability to administer particular services inside the jail, I'm not sure that necessarily applies there. I mean, maybe it's a subset there also, but it's a series of flags, certainly. So one of the other
that could remain being those.
Right. So one of the things that we would like to have as a project, and we'll talk about tomorrow in the Trusted BSD BOF, is do we need a new privilege model for the operating system? And since we've already gone on,
would be sweet.
Right. So we've done the kernel work to do a lot of that right now in FreeBSD 7, because we now have a list of privileges and they're named individual privileges and they're categorized and so on. So we can a logical next step there is to move us towards having bit masks of rights, right? And we can certainly abuse that and use that in this context as well. But I think I think the virtualization aspect is more interesting because I think that the privilege stuff will kind of fall out. What I'm worried about is, are there other models than don't allow the subsystem, fork a new instance of the subsystem, share the same instance of the subsystem? I think
well,
there
it seems
aren't.
to me like if
right?
you want to run like access to libkvm within.
But I think I think of libkvm as different because it has to do with global integrity constraints as opposed to a service offered by the kernel.
Why is there any reason to restrict that use within the memory that your jail has allocated?
There is only one piece of memory.
Yeah, there's only one KVM no matter what.
Yeah.
But
we can't subdivide KVM unless we turn it into a virtual memory. It's not going to happen.
Well, we might as well
What
turn
I'm
it into
saying
syscontrols.
is, if you know what the
KVM's
maps are, the mappings of the virtual memory, you can say,
Well, we don't do it at page granularity. Is the problem.
Right.
We share individual page can have information and settings for more than one virtual machine.
Because your routing table for one instance can be the pieces of routing table.
And now with multiple routing tables, you could even subdivide the.
Yeah,
I mean, it get really crazy.
And they could be in the
Or
same
maybe
page.
we would have
It's
multiple
not
routing
easy to do
tables,
that.
one per image.
I think KMEM is sort of out of scope. I think we do need to move to syscontrol universally to make this
I
work.
think KMEM is one of the things where we can use the IBM argument and say that before IBM could do it on MDS, they had to add special hardware for it. And Intel is not going to add special hardware on the bottom of the CPUs, so I don't think we should even expect it to be possible.
It's a good long-term goal to dispose of KVM entirely.
Well, actually, it is there if we're going true virtual machine,
No, it's not.
where you're virtualizing the machine.
Yeah, but that's a different level of things.
Yes, that's actually what I'm trying to stay
Well,
away from the word virtual.
so maybe we should veer briefly back onto the conversation about virtual network stacks. But maybe we should talk a little, just for a moment or two more about this administration interface, because I think that really drives the design of what sits underneath.
But again, that's not a virtual network stack. This is opening it up to a virtual image or a virtual...
Right, well, and I think we should do that.
That's actually what the actual
the
topic on the
framework.
conversation was: virtualization, not virtual network
Yeah.
stacks.
So suppose we have a system called Vimage that says create me a new image and place me this process in that image, or something along those lines. What are the arguments to that system call? We have a list of subsystems that, because we live in a world with kernel modules, has to probably be strings, reflecting the subsystems that have registered themselves with Vimage.
Maybe a bitmask representing permissions for things that root can normally do.
Yeah, I think that's useful.
You know,
Which is our privilege list.
And I think some
Do we want that to be
structure of
added for
this-
modules too, though? So once again, it'd have to be something name-based because modules might have their own permissions that they may or may not want to inherit.
I think there's got to be an arbitrary list of attributes, like back to the scheduler. Here is some set of attributes that just churns around with it, and the kernel can be check it. As long as it looks like the framework is, even when you're not creating one of these, you're in the default configuration, it's going to look like in the code that you are under one, right? So
I mean, as Brooks says, it probably makes sense for us to do the bit of work where we move all the things into structures. Should probably happen anyhow, even if you're not going to run it, so that the code just always looks that way.
Yeah, a fair bit of the macros would become much simpler if the only difference was whether we had a single static instantiation or a single instantiation of the structure always, or an array. I think things would get, rather than the current thing where they might be globals scattered around all over the universe, or there might be this structure.
right.
You can't have that.
That's what the code is.
Which is what I was.
Right now.
That's why I was asking earlier, just to be educated. I wasn't arguing with you. I agree.
You always have some variables that will have to be global.
Oh, I agree. What I'm saying is that in the current code, there's the if-defs, where there's the if endef
Go down
image
more.
at the top. There's the code. There's that set of global variables which disappear and move into a structure. And it would be much easier if we only had the structure.
Yes.
Right. But we recognize this tension exists, right?
Yeah.
There's little reason not to.
The way I said, we committed
So
all.
this is temporary.
So we committed all looks like this with the structures, with the structures coming and going, so that if we have incredibly broken it, it doesn't stop the whole universe from using current.
Okay.
Okay, so if it takes us 6 months to get it cleaned up, that's okay, because only the 17 people in the world who are playing with it, right, are hurt.
Well, no, actually, it'd be better if I
I'm
want to
not-
run an old kernel and a this or modules. Flag days.
The size of the if-defs in net if.c make me believe that's not true.
Well, having looked at
That
what's
my
the
maintenance
but
would be
mechanically,
hell.
if you look at what if you come out to the macros, most of the macros in the compiled out come out to pretty much a knot.
That's not my concern. My concern is that there's a whole lot of code that's different. There's 20 line segments on each side that vary substantially in some of these functions. And if we moved everything into the structs, and we just did it in either case, those changes would go away.
Yeah.
At least be reduced.
What I'm
It would
saying
be
is that would be
much
the second
simpler.
step. First you compile it as it is now.
Let me talk about the tension here. So one of the tensions here is that we're worried there's a performance overhead. Right? And we don't know, we haven't quantified the performance overhead, so we don't know how bad it is. So one of the requests we've had is make it all conditionally compiled so that if there is a performance header, it will go away, and so that we can objectively compare the performance of the two. Right? So we'll have a compiled out case. The problem is that all of those if-defs, as you're saying, turn the code into garbage, right? It's not the code, but the diff is garbage, right? Because you can't really read the diff. You can't look at it and say there are all these style changes and everything gets moved around and all the code is duplicated, right? Which makes it hard to review the diff.
Right. I think that we can achieve the ability to compile it in and out at a much lower impact in terms of duplicated, substantially different code. But if we're willing to make some consolidation and make some more aggressive changes.
But what you're saying is we have a prior step. Before we commit this, we have a prior step where we do the structurization of the variables as a previous commit.
Yeah, and it may be that those will properly end up in probably _var.h files instead of in the current v*h files. And
the diff will reduce in size.
And frankly, I think that's probably going to be okay. There might even be cache benefits.
Yeah.
So the question is, how much does the lookup cost? The indirection cost?
Yeah. Well, no, it's not necessarily an indirection.
There's not even any indirection if you statically instantiate the structure.
I mean, so jumping through the structure isn't the issue.
So there is another issue. There are a couple of issues we haven't talked about, and we should probably think about wrapping up in the next 15 minutes so we can have dinner.
Dinner's at 7, by the way.
Yeah, but so one of the things we haven't talked about is the impact on ABI. ABI is the thing that's coming up more and more, right? So by moving all these things into a single global data structure with a fixed layout, we have now encoded, with respect to table offsets and so on, the layout of every field before a field that you care about, right? So we are basically frozen with respect to the layout of all global variables from the point where we merge this onwards if we want to support their access from device drivers,
all
for example.
Global variables or just all sets of global variables? Seems that they're substructure.
If you resize something that happens to appear at the front of the data structure.
Device drivers have nothing to do with this.
If only.
But the compiler will now have a global variable that's a structure, and you'll say struct.field6, and that's now kind of hard coded.
Yes, yeah. Well, if you change,
that's the problem.
If you change the size of the first field in the data structure, everything else moves, and everything which is compiled with respect to that knows the offset, right, and not the symbol name, which is what they use today.
Well, that's everything. That everything is only the networking code that is here. So I'm not aware of perhaps only a single driver that directly attempts to. It might even be zero drivers.
Well, we know that the Chelsea driver is affected, right? Because the Chelsea driver does TCP offload, and it looks at the data structures that are inside of the remainder of the TCP/IP stack. But we also know that the firewalls, which are loadable kernel modules, and which we try not to break a whole lot, do reach around and do things with connections and connection layout and stuff like that in global variables. Now, arguably those are bugs, and they ought to be fixed, right?
They do them by function.
As soon as Kip commits his patch, they're going to do them by functions, but they don't currently do that. But I think we do need to be very careful because I think there's a lot more to this.
We've added ABI issues.
Yeah.
We've compounded the issue with ABI issues.
Yeah. The already are the nasty ABI issues. And I don't see there's anything to do about that, but I think we need to be aware of that if we're going to accept it.
That doesn't mean we shouldn't do it.
Right. No, exactly. I agree. But we can't go into this and say, oh, there are no ABI issues because there are massive ABI issues.
Excuse me for a sec, but Tech wants to go home for dinner. So he's asking about, how long will we be, and can we turn off the EV now?
Could you give us 10 more minutes with the projector?
Okay.
Oh, let's skim down the diff.
Do we want to skim down and see if there's any more stuff that's...
Yeah. Well, my question is, you're creating a UMA zone for every instance with the same name,
right?
Whether that's okay.
Sorry, say it again.
Yep, there's a UMA zcreate.
UMA zcreate. Yeah.
Okay, that's a huge issue. So essentially, this shouldn't be. We should have a single UMA for the same
module
subsystem. So this here should be, this part here should be done only once, and this zone should be shared probably by
That's
all,
a bug.
all the instances.
Unless you're using UMA zone limits to enforce resource limits on the use of resources in
zcreate needs to grow.
And also,
grow a new argument.
if you have only one zone shared by all virtual images, then I can trash your image.
Yeah.
Right?
Well, can we have then some kind of soft limits so that we have like a global limit and then per.
Or what you need to call it is go ahead and create separate zones, but they have to be called different things.
Yeah, that's.
There's to be like a new underbar number.
Yeah, it could be that the bug here is that.
But then we will be wasting tremendous amount of memory.
Goes above a cache for every
memory,
zone.
or we have things that can, or you can have one stack that can block another one on zone limit.
So there's also an issue of memory flowing between zones. So certain memory types flow between zones like mbuffs, whereas some other memory types, presumably like IPQ entries, don't flow between zones.
So yeah, this is not a trivial issue.
And in fact, the IPQ is one that does have a maximum, because it's got max and IPQ update calls set limit.
So again,
which could be different
you guys,
images.
What's the less evil? To have a shared zone for say PCB or what is this? Oh, this is input queue.
Just enforce the limit elsewhere.
No, I can't do that.
Why not?
I just think that there's way too many security issues involved with
Or just have a front end, just have a different front end to the zone, which...
You could pass in a resource limit instance into the zone when you use it for allocation free.
Psychological cleanliness.
You could just have a per zone front end to the zone.
So that all code and all
Well,
structures.
let's scroll down 5 more lines and see what we see next. That last 5 lines was really
good. So you've just been code reviewing the diff this whole time?
Trying to understand the
We're using the diff as an example.
It drives conversation, doesn't it?
Into the ground.
Okay.
Yeah, very good.
So tell us about threads and processes and this notion of a current virtual image.
There's no current virtual image.
Right.
There's current VNET.
Right.
That's what, now, is that what it should be in the end? If we actually had the full, I'm back to, we've kind of talked about a framework we do a lot within, but it looks like we mostly implemented the network piece of it.
Because it was the
Which is fine. But then do we really need the notion of a current Vimage, not a current VNET?
Yeah.
Okay.
Right. Well, tell us about what you've currently done for current VNET.
Okay. So why I think I needed current VNET in the first place was that you get the function called ref either driven from below from the network drivers, where from the network drivers upwards to the socket layer, functions get called, or vice versa, or you get the
clock
you get something kicked off of timers. So if you go from below to the socket layer, then if each network interface is always assigned is associated to a network state instance, then you know where to process where to look for your data. The current VNET helps us only to implicitly pass this implicitly pass this argument to among the function calls. So instead of extending function arguments lists, we use current VNET, which is thread local variable. So if the thread is stopped and continues executed on the different CPU, we are the proper thing.
But
so
of necessity, though.
It only saves us code churn if we wish to extend all the networking functions with another argument pointed to a VNET, then this thing can go away.
Well, by necessity, though, you have edges between bits of code that use one virtual network stack and bits of code that use another. And the classic example of something like that, and I know this from the Mac framework work, is NFS, right? You're running along in a thread for a user process, and you're in one virtual network stack or with one MAC label, and then you touch a file system which is backed by a socket that's associated with a parent instance that's gone off and set up NFS, which is possibly in another virtual network stack because it's accessed via a file system that's shared by 2 different virtual network stacks. So now the file system, the NFS instance discovers that its TCP connection is closed and it wants to reopen the TCP connection. And it is very important that that TCP connection use the right virtual network stack. So that will presumably drive you to go and look at pieces of code that save and restore
current
So
network.
we have macros which basically allow us to stack, push and pop this current VNET. So it's not overwritten, but it's stored and restored. And while we are not in the network stack, then this current VNET should be pointing to
whatever
0.
And as far as this work, we're looking at getting this in 8.0?
That would be
in full, or
we'd like to come in real soon so that we have time for it to, because this we really need to have this. Part of the development for this requires that it comes in so that we can start integrating with other people and moving through these stages of removing the macros and
but as
doing
far
this
as
stuff,
figuring
right?
out what to do with jails and how it looks like a cohesive thing and not two different things within the kernel.
Well, we're using this uses jails to some extent.
It seems that jails should use this.
Yes, but until it's here, it can't.
Right. But I'm saying is that the goal of 8.0 is even to clean up?
Well, the goal of 8.0 is to get some distance down that path, but we don't know how far we'll get. But if we don't start, we know how far we'll get if we don't start.
Right.
Okay, for example, here we could have used, look at, this is input path, so the M buff has a pointer to the inbound interface, and the interface is always associated with the network stack, so we could have deducted the current VNET without going to that thread local variable. So we could
You could have used it as
M result pointing to interface and seeing to which VNET this interface belongs.
But just for clarity, because all the other functions do it, it's been done that way here too.
An additional benefit of having current VNET is that if we would be using what I just described, M pointing to IFP and then to current VNET, if we have debugging turned on at compile time, then this macro will compare the current VNET pointer and what we are trying to feed this macro. And if those two do not match, then we have an assert and it detects some inconsistency in the code. So therefore, I think it's good to keep the current VNET because it can be also used as an additional check, consistency check. So that it doesn't happen that we have current VNET set to one VNET and operating on an interface from another one.
Network order reversal.
Right, but it does mean, but for example, in the NFS case, it basically means that you have to perform an explicit context switch of virtual network stacks whenever you pass in between, along these boundaries.
I admit to not reading the NFS code recently. But shouldn't that be in a kernel kind of space, like protected from the
Well, you're
process?
on the same core stack, right? You're on a kernel thread acting on behalf of a user process, and you're walking down VFS, la 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 la. Oh, look,
it's a socket.
I have to do something on a socket, and we already have problems there because we don't. Historically, we've not done a good job of keeping track of the credentials originally used to do the NFS mount and using those to reconnect the socket. And a bunch of bugs got processed in the last couple of years having to do with, oh, I used the wrong credential to reopen it, and it turned out later there was an IPFW rule that affected the user's credential, but not the root credential that originally mounted the file system, and stuff like that.
So the real now Julian has a really good picture of me going,
But it's more explicit context,
The real question is, after all this goes in, when are you going to update the book?
He's the boss. The boss is in the top row over there, ignoring all that.
I think this kind of adds some life to the book.
I think somebody wants to co-op the role.
Welcome to our
Okay, let's go down 10 more lines. Actually, we should probably let him go. The technician go.
One second, Robert. Before everyone's going to run away, if we want to get this in, wouldn't it be good to get a patch that just does the variable consolidation, so we could do the performance testing of this and have Chris or whoever run some tests, so we know if we need it or if we need it optionally, or if we can just commit that diff and have the first step in.
Do you think we should have another? Do you think we should have another BOF tomorrow, and we should come up with a plan?
Okay.
I think that sounds
But
like a good idea.
it seems you can do the performance checking without it having to touch CVS.
Oh, right.
Yeah.
I mean, we really should know.
We can produce another per force branch.
And I think we should be really cautious about doing a image or.
If we're serious about it, we could rename all the variables v_now.
Right.
The problem of my if index array went away.
Yeah.
Which is something that I've started to get bug reports on. So
Yeah, we should deal with that. The worst thing is the code actually attempts to correct things.
Yeah.
And it's panic.
get it over with.
So I think I should just turn both of those checks into KS or it's in
some open source top the IMAP proxy, so
yeah, they tend to. I think a lot of people.
Hello. Part 2.
Return of the Jedi. The Empire Strikes Back.
Attack of the Clones images.
Yes.
Hello.
Attack of the images.
Starting part 2 of virtualization. Firstly, is there anyone here who wasn't here yesterday and who has not a clue what we're talking about?
Repeat everything.
Okay, so firstly, before we get anywhere, does anyone have any questions or thoughts that they've had since yesterday and would like to sort of like get some clarification on? Okay, yes?
What is the one? Let's assume this code goes in. What's the ongoing maintenance that was required, or what changes? What do I have to look for when I'm changing code, developing things in the network stack? So what's the difference compared to today?
What's the difference in maintenance effort for maintaining the new code versus the old code? There's a very small difference, and it's just that you know which bits are virtualized and which bits don't. You just have to keep that in mind. There's not really much you have to do. Brooks?
Well, there's the new issue that you now have to be aware of more ABI issues because of the structures.
Yeah, basically, yeah, that's a good point. That's one that gets the issue had thought of.
And unless we succeed in making sure we only ever have the structures, you have to maintain the variables in 2 locations until that's fixed.
Yeah, I think probably that will, at least in 8, I think that will go away pretty quickly. So Brooks is saying that if we, in the initial version of the code where it can be compiled away, we have the same variables in 2 places, one in the structure, one out of the structure. And our thought is that in 8, that would go away very quickly. If we do MFC this to 7, then I would say for the life of the 7 branch, we would continue to do things the same for ABI compatibility reasons, so that people, so that we maintain total ABI compatibility for the turned off state. But for the turned on state, we assume that people who want to turn it on know they're going to break the ABI, and people who don't want to have the ABI change can leave it turned off. And that would require them to keep the variables in the same, in 2 places.
Well, we could maybe just set up the struct depth. We could play maybe some games. It's not quite a difficult.
It's not.
It would be ugly.
Yeah, I have to say, I mean, I would like very much to have seen this in 7.0, but I'm becoming increasingly convinced that merging this to 7.x is not really a good idea.
When we've got it in 8,
yeah,
we can look at what it looks like in a 7.0 branch. Marko has it in a 7.0 P4 branch now already, so we know approximately what's there, but we can try it out first.
I really don't want to see Roland 8 cut with the split.
Yeah, no, I agree. I think it would make a lot of sense to make that change.
to get rid of the duplicity. Duplicity, yes.
So what you're saying is in A, we will have the global structure in A. In the,
I think if it goes in, that's really what we want to do. I think maintaining things in multiple locations is going to be hell, and people would also have a tendency to screw up and break the ABI in the Vimage case if they didn't break the ABI in every case.
There's all sorts of other things too, like well, the static initializers moved, and what are the chances that people are going to correctly keep the static initializers in sync with the additional copies of it at the same time? I think I agree. The goal would be to not greatly increase the cost of maintainability, and one of the costs of maintainability is obscuring initialization of all the variables and so on. And I think this sort of counts as obscuring. I realize there's a phased introduction, but at the end of the day, I think we don't want to be maintaining 2 whole instances of every single variable in the stack.
That's true, though you could conceivably move to having the initializer function, and instead of initializing and with the same code initialize the globals, as opposed to having them initialized statically. So you initialize in one place. Basically you could simplify. Part of the diff at the moment is to have a minimum, is to maintain a stability. Once we're sure that what we're doing with the initializers works, then initializer functions, there's no reason the initializer functions can't work on statically applied version of the structure, for example. So there's that. Now, while everyone else was enjoying their ice cream, Marko and I were talking with the guys at Juniper, from their perspective was, how is this going to affect our tree, which is, like some percentage, 60% FreeBSD, 40% ice cream. We basically came to some thoughts as to how we would go about applying this. And I'd like to just put down on the blackboard the thoughts that we sort of had, and maybe David can correct me if I get this wrong. I just want to be curious. Hang on a second.
They think they have a plan. We'll see if there's anything.
Now, the way we would do this would be to basically iteratively reduce the size of the diff. So the first part we would be applying the macros which exist at the moment, and these macros take, for example, RT tables, and turn that into, the macro is V under RT under tables, and both. So we would apply this everywhere in the source code that exists, so that the code it has, and this we would then hash define at the same time. Also 1A, we would hash define that to be that, pretty much, definitely. I mean, it's like not even conditionally, just that is that. So we go through and make a change, and a large amount of the diff, for example, goes away, and then we can just MD5 the outcoming binaries and say, look, nothing changed. Okay, that takes a large amount of the diff out of the picture. Then the next change would be part 2, is we would structify.
No, 1B.
Which is 1B?
No, scroll up, please.
To see controls?
Yes.
Oh, yeah. The second part would be the syscontrols, which are slightly varied. We would implement those once again as a one-to-one mapping, so that the new syscontrols are the old syscontrols, but we can prove that they're not different. And that makes a lot of this diff, for instance, a lot of this diff goes away. A lot of other diffs go away. And it allows us to concentrate on things which are really important to look at. So we've gotten rid of a lot of that. We'd probably also apply the
apply the macros which are at the top of the various functions, but they will be defined to nothing. It's just a case of diff reduction. We know they go to nothing. There's an example there. Yeah, ENET, VNET, INET, current VNET. That wouldn't do anything until we turned it on, but we put that in there. That basically, an awful lot of files contain nothing but these diffs. Okay, so
V underscores and the init.
the V underscores, the sys controls, and the init functions. If you define those three macros to be there and apply them, then pretty much, I don't know exactly, but maybe 75% of the files in the list actually drop out of the diff. It gives you a much easier job of looking through the diff and seeing what the actual changes are. So our suggestion is that we would do this, and this would actually be good for our friends at Juniper, because what they would do is that they would be implementing these themselves, but putting a different definition for the macros eventually for their own code. If they don't happen to want to have the virtual image stuff at all.
And what it also lets us do is we should be able to MFC that stage. So porting code from 8 to 7 is not a big deal, right? I mean,
so it looks the same, the
FreeBSD,
diffs don't become hugely different.
Right, we want maintenance of 7 not to go down the
Keep in mind this will invalidate all outstanding patches against the network stack that anyone has, right? Because this changes every function in the network stack.
It changes every function, but it's only a change to the diff, right? And not all, as opposed to being a change to functionality.
Right.
Yeah,
So I'm talking about.
This won't apply any longer.
Yeah.
And if I have 50k of diffs, you will make me very upset.
Well, how did you make your diff? And if it's out of purport or out of an SCM, you integrate and produce a new diff.
Yeah, you have to resolve all the conflicts.
Well, this happens. This is going to happen.
There
no
will
matter
be
what.
conflicts.
Yeah.
Right.
I mean,
Right, no, I agree.
It's unavoidable.
But no, so what I'm saying is, when you're talking about MFCing to 7, remember that every vendor out there who has any local changes to the network stack will be forced to manually integrate every one of these changes in order to continue to slide along the Relink 7 branch.
That's true, and that's what has been discussion with Juniper, who we think is probably the most affected of these people. I mean, this is the way they would rather go than to have to do logical changes.
Right. So I'm not saying this should go into 8, but I think that Juniper is not the only set of people with a very large set of changes against our network stack, and we will make it very difficult for those people who have large patches against the network stack to continue to adopt
But you're going to have to do
them.
it anyway, and doing it in a small piece that's very mechanical. It's the whole thing. Do you integrate often, or you integrate not so often, so that the patches build up?
I'm okay with this path. I'm disturbed by the idea of contemplating an MFC.
Seriously?
Yes.
I think it's crazy.
Well, I think that my comment on that. My comment on that is that then you've got a large diff between current and 7, which means that it's hard to MFC other stuff back, in a mechanical manner. And every change that we make down, every time we MFC anything, it's going to be an awkward MFC. It may be easier just to knock them down straight away and make that cost once.
Yeah, but where do you stop?
Well, again, that's a good question, but that change is very mechanical, is easy to understand.
It's an easy to prove change. That's the thing.
I think, and I still have a FreeBSD hat on. We don't want to make MFC to 7. It's hard. No.
The reservation is only till 5 p.m.
Just the change of the variables.
And there's something else in the door that says stop
and no more.
Class
Just
I don't know. As I said, there's all sorts of very sad-looking students wandering up the door, wondering what's going on.
And so, is the embedded session going on the other way?
No, there's students up there as well. So we didn't get there in time, and the students who own the rooms actually got the rooms.
Right, we have to abandon this room.
Yeah. Anyhow, that's probably enough information, but we're looking at that as being the first 2 steps to add those macros to Structify. and then the stuff that goes with that. And does that make sense to everyone?
I think for a model for getting this into 8, this is a reasonable plan.
Yeah. The MFC ability is open to question, but we'd like to get it into 8 this way.
I would suggest, in terms of further minimizing the diffs, that we consider adding access and macros for statistics, and then hiding the v change behind that macro change. Because we can talk about this afterwards, but basically, some of the diffs here, even if they're just the v changes, are somewhat gratuitous, and I think that we can actually even further minimize those.
If somebody could read French, the sign on the door maybe looks like it's telling the students to go somewhere else. Can we get a French speaker to read the door sign, please?
Resident Frenchman? We knew you were in the project for a reason now.
So are we going there if that's out?
Just edit this out.
I think that
What should this look like in 8?
Okay, yeah, I actually.
Yeah, this stuff's not really very useful on a recording anyway, really. Discussion.
We're going to email it to you. We're going to email that a lot more. We might have the room actually. Oh, yeah. That's what's on the card. Yes, it's from what was had.
Maybe the sign doesn't say anything.
All right. About 5 minutes. I'll sit down to you.
Oh, so does that mean we've got the room installed?
As far as I
Yeah, there's very sad looking students still arriving at the door, but they're
Okay. Well, is there anything else that anyone wants to discuss on that?
Right, okay, so let's move on to the rest of the plan.
Okay. Yeah. So the structifying is the next stage, and that means that all of 8 has these functions in a structure. And the next stage to that is to add the framework, I guess, which would be the actual framework for virtualization, which would be the those pointers that I showed you before. And then once that's in, then we can do one module at a time.
I thought the structify was the next stage was we would move to a global structure.
Oh, yeah, well, that's part of it. I mean, we'd structify, but we would only just implement one copy of each structure, basically statically defined. So you would take that structure and right where you've used it, you sort of like declare one of them, and the macros are then changed to point to. Let's say the global structure is G, and G dot, RT under tables, T, P, yes. So that would compile pretty much as efficiently to run as what was previously before, which was just the static pointer. So after we've got this point here, we should be able to do basically performance testing and see if we haven't screwed anything up in this one, because it's a good point to check that our theory coincides with reality. Of course, if it speeds things up, we may not want to go any further. So once we've got the structures, and that means we also have to put the initializations routines. As part of this, we get the init routines.
Do we?
Various initialization routines.
Do we necessarily?
Yes, because we can't statically. Well, I guess we could statically give values to them.
Sparse initializer is the first step, or is it easier to just do the init?
It's probably better to do what it could do. First step you put it in, but it's sort of complicated to work out some of the values. It's probably easier to write the initializer, which you've already got written, and to test it. Right. At this point, it's a good time to test the initializer. So if we know the initializer works, then there's one less unknown for the next step. So the next step would be to put in the framework, which would be the per thread pointers to the current, whatever it is, and actually start treating it as if it's the first of many. know what I mean? So instead of saying this is, you know, dynamic, we basically have statically defined one. At the moment, this is not really statically defined one, it's statically defined. But if we then go to the point where we start accessing it via the pointers, you know, where we make these, we redefine the initializers and the new routines, and we redefine the macros so that they're actually accessing it by the method that will be applied. And then once that's done, we can do one module at a time, because pretty much a module could be done independently, or at least some group of modules at once. Like for instance, the INET stuff that Marko has done for IP version 4 could be done all in one hit, bang, done. But we don't have to touch, you know, anything else. We just see how it goes. And if we add the utility that allows us to change something after that.
So 2 would be Structify, 3 would be Vimage, and some example.
No, 3 would be go from Structify, direct struct, G dot, to G dash, G arrow.
Yeah, basically it becomes G to arrow to RT, blah, 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 blah.
So there's a few code changes you have to make, you know, just syntactical changes.
This is how the macro defines out. And we start accessing it by the, it basically checks that we know the pointer at every time that we're supposed to be pointing to and how we get that information. So that init, VNET, INET macro would stop doing nothing.
Okay.
And the V under macros would start to be slightly different from just being a global. That's the point where what we actually compile out to is different from what we had before to a greater extent. And once that's done, basically the framework is done. At that point, we can, you know, from there on, we can be pretty confident of what we've got, and we can start moving forward to doing little modules at a time.
And part of the discussion kind of along this way was if a vendor does not want to buy into Vimage, how much change do they need to do to their code base, right? So either I just have to tolerate what FreeBSD did for Vimage, in which case in the vendor's code you repeat these few steps, much of them quite mechanical, MD5 it, be happy on your own. And like you may stop at 1, you may stop at 2, you may even go as far as 3, and then I have to buy off the you know, per module, but it gives the vendor some flexibility. And I wasn't just thinking about Juniper, but any vendor, if you love it, you go full-fledged, and you have to go, because you have to analyze quite a lot of your own functions, right? All the work that Marko's done, you have to do on your own. And I think this makes it an easier path.
Yeah, if you stop at the end of 1, you basically allow yourself, or even if you've done 2 with the static, you allow your own modules to just keep on using global variables if you really want to.
Without a whole lot of thought.
And certainly at the end of 1, you don't even have to change your own functions because this stuff maps out to be the global variables. These defines map out to be global variables when they're unrolled or evaluated. Then your own code actually using those global variables doesn't actually have to be changed at all theoretically. Which does make an argument that we can keep using the V underbar macros for variables which have been virtualized as a coding practice.
And as far as the MFC to 7, I claim step 1 is virtually a set across your tree. I mean, really a mechanical set. So that's why I didn't consider that a huge merge problem for a vendor.
I might be more inclined to do it if we actually did it with a set.
Right. Oh, seriously, I kept saying I really expect this to be.
So the vendor can use the set.
Yeah, exactly.
Because if we don't,
exactly. No, I'm serious. We should do it with a set.
Yeah.
Or a Perl script, or you know.
If we can literally do it, that would make it less painful. Might make it.
That might make the tree in a project.
Yeah. That might make the win. That might tip the balance in my mind towards making MFCs to 7 easier, rather than avoiding perturbing 7. But
yeah. And so that basically gets us to where we want to go, and then at that point on, it's a case of tuning things, making things more efficient, and experimentation as we go. But there's no one screaming and yelling, which is sort of like scaring.
Brooks did that earlier.
Well, see, if there were people screaming and yelling, I'd be happier that we've got people actually taking notice.
So, for now we have a 4-step plan. Is there a 5th step?
Improve.
Well, I think there's still the bigger question of what this leads to. You know, part of it's a framework and part of it's a first subsystem. And
yeah, because what I'm missing at the moment is capabilities management, API. I'm missing something that will be suitable for virtualizing the entire tree and not just the network.
You do get some of that with this.
Well, what assurance do we have that the interfaces that are going to go in this massive sed script and rewrite the entire CVS repository, invalidating all outstanding patches, are in fact the changes that we need in order to do the next step, which is the rest of the Vimage stuff that we've discussed here?
So what you are suggesting that we might get without v underscore macros perhaps?
No, I guess what I'm saying is...
If we don't have a good view of where we're going...
I think we have to go through this.
Right, so let me re-express the question, because and it's not intended to knock aside the value of the work, but I think the legitimate question is, we're going to destroy every outstanding patch against the tree. Let's do that only once, right? So let's make sure, so are we clear that the set of changes that we're discussing right here is going to be what we need to implement the management APIs and the services that we were envisioning yesterday when we sat through the virtualization meeting?
I believe they are. I believe they are, and we're trying, one of the reasons for doing macros was to try and hide the underlying implementation of a lot of this stuff. So if, for example, we get somewhere and we decide, oh shit, we have to do something, a lot of that gets hidden by macros.
Right. So we've gone through and named everything here: VNET this and VNET that, and so on. Just yesterday we were saying
the naming is actually indicative. Remember, every module that you virtualize has to have its own structure of variables which have been taken from the global context. And so the init, VNET, INET, the init VNET part is sort of like constant. The INET is saying the name of the module.
Right, so but if we're talking about making the whole thing vimage, should VNET be vimage?
VNET is like for the networking, so I'm using this like VNET, process groups, CPU, this kind of, this throughput.
Can you show us the definition of init, VNet, INET?
Sure.
And I see only VNet has module support, not any of the others?
Right now?
Yeah.
There is some work in the tree, or in a tree, for instance, per virtual machine load average calculation.
But I'm talking about, suppose you want to add a module to something that is not network.
It's up to you to decide what you call your own functions, your own macros, really. We're just making a suggestion of a way of doing it, but when you see that, we know what it is. But
Julian,
yeah.
Where would he hook it off?
Oh.
At the moment, your top level G is a VNet thing.
Well, there's a vimage, and then there's the VNet, and then there's the modules inside VNet, right?
Yeah.
And right now, there's basically an extra layer of indirection that, except for this load average stuff, is unused. Except that I think that's the really, in many ways, that's what's most interesting to me.
Yes, the most interesting is the ability to virtualize multiple modules. And it basically is modularization, virtualization on a module, on a per loadable kernel module basis.
Yeah.
Right. So it sounds like actually, and load average is not all that interesting because load average is an inherent feature in our kernel already. A much more interesting example would be one of the System 5 IPC modules, which people can do already load dynamically in their current systems, and that would make a lot of sense to virtualize. Or one of those other modules along those lines.
True. The only reason Marko was playing with load average is because it looked like something that he could do it in one easy bite.
I bet you were hoping it wouldn't change either, right?
The proof that something else could be done.
But I think maybe what we actually need there is a more interesting example, because it sounds like it sounds like it does do what we already asked, which is that the naming scheme be something that won't change when we do get to this more general thing. But I think we need to prove it to ourselves before we run sed on the source tree.
Well, how do you prove it? I mean,
well, you do a worked example. right?
Take a poll on the main street. Excuse me, what do you think of this naming convention?
Right. No, you do an example of System 5 IPC, and then you wonder why the string VNet appears everywhere in System 5 IPC, or you discover the string VNet doesn't appear, and then you say to yourself, I guess it did actually do what we wanted.
Yeah, but the VNet would not appear in if you were doing System 5 RPC. It probably has RPC or something. I don't know what you call it.
Would be good. Yeah.
Yeah. I mean, those macros are specific to those kernel modules, right?
Right.
So for each kernel module you virtualize, you define a different set of macros.
I think we're agreeing entirely, but what I'm saying is I'd like a worked example that shows that the result is what we want.
So you're saying pick what's the absolute smallest module with the least amount of code you can think of, do that one also, so you have 2 examples. Is that what you're asking for?
I'm asking for something that is in fact a loadable kernel module.
Yeah.
And not
I'm
something.
just trying to think which one would be a nice.
Yeah. What is the least?
Jam or something.
Yeah. Or something which we're not even sure we want to virtualize, right? One of the IPC modules is probably good, right? Because that's going to have the slightly more complex memory allocation behavior and namespace issues and things like that.
You say we have to do this before we can proceed?
Yeah.
I would certainly be happier.
I
would be happier.
How about the POSIX semaphore code, UIPC SEM, which is it's a little like System 5 IPC stuff, but it was written, after the year 1990, and therefore conforms to some more recent expectations. But it isn't tied into anything like VFS or device driver frameworks or anything like that. It is simply an IPC subsystem.
It's a possibility, I guess.
Well, you're going to run sed and rename everything in the network stack.
Yeah.
I really don't want to see it happen twice. Right? It is very important that it not happen twice.
Well, there's settings, you just add V underscore in front of everything, so it's...
Right, but there's all these init VNet things, and take this as a devil's advocate view of the world, right? We have an enormous investment in a source tree that's used by hundreds or thousands of companies to produce their products. We're going to hundreds or thousands, right, to produce their products, and we're going to invalidate all of their existing changes against the tree. It is really important that we not change our mind 2 months later and say, oh crap, that should have been a pointer, right, or whatever it is. So I think we owe it to ourselves to try it out and make sure that it does work the way we said it's going to work.
I think the aim is to get it so that it's one change between, say, 7 and 8.0. I don't think it really, if we change our mind about something between, May the 30th and June the 30th, which are both pre-8.0, I don't think that's going to affect anybody.
I have very large patches against the network stack. Please don't break them more than once. It is very important to me. It will cost me months of time to rebuild those patches.
I thought the course takes care of all that, recommended.
Your flippant answer is very appreciated.
But seriously, I thought that the course could help.
No, it doesn't.
These mechanical.
It cannot help with random renamings of things. And these aren't random renamings, but these are serious renamings of large amounts of code. Nothing is going to help with those automated merges, right? These are going to be conflicts against almost every line in the network stack.
Why wouldn't you run the same set script on your own code?
Significant changes to the network stack, right? Significant changes. All the chunks and the diffs are going to be really big, and they're all going to be 100% in conflict. That is not going to go away by doing renaming of things. It's just going to produce a massive conflict. So I'm willing to resolve it once, but I'm not willing to resolve it twice.
No, you don't have to resolve it. You're going to have to produce a new diff. You have a full checked out copy, not a diff. You can apply the set script, and that's the whole point, is by making the set script available, your diff is invalidated. The sources you use to produce your diff, the set script should, right, if we've done it right.
So if you've restructured, say, there are some people in the room who, for better or worse, have probably restructured large parts of TCP in their perfluous branches, right? For them, merging these kinds of changes more than once is going to be a pain. Set scripts allowed for it, right? Those people in this room are probably not
really set scripts don't care about the structure of the code. All they're interested in seeing is this is a global variable that I've been asked to change. I recognize it. I'm going to stick a V on the front of it.
That doesn't. When you start sprinkling part 2 or part 3 can cause you some trouble. So maybe that's the part that you're at, is the init function that goes to the top of every function. That's probably the one that will cause you the pain, right?
Yeah,
so you're really saying
I'm less
once
concerned
that
about
means
v
that-
underscore this, right? What I'm concerned about is init functions and dereferencing and all these other things. Things that rearrange the structure of all of the local variables in every function, stuff like that. Things that cause significant disruption to the source code. We're asking you. I think if you listen to what we're saying, we're saying
I'm listening, but
we're
I'm
saying
thinking
there's not. It's not that there's no tolerance for one change. It's just that we'd really appreciate it if it were right that time.
I think you're adding unnecessary hurdles at this point, and that you're adding hurdles which are like it's going to be harder to do this stuff ahead of time while we're still at the same time keeping track with current and doing merges every day and coping with mismerges and stuff like that, than it will be to get the stuff into current and then prove that this works, and if it doesn't, give us a week or so of time to get it all settled down before you update your patch, and it's probably able to get more done in that week than in a month before you've committed it.
You're saying, trust us, it will be right.
Trust us, it's been working in one form or another since 2002.
Do we have an idea of how many patches are floating around?
Yes, many.
There are many,
Hey,
but
I'm
that's my
private. I
point
think
today
I
is
have 50
is you have to do
pages
merges every
in
now
my
and then
private
anyhow.
phone tree.
And
What is also, I think, important here is that to have an updated document or paper, not in the sense of a research paper, but written for programmers. For
yes, and I
developers.
I think that's very important too.
So people who are tracking FreeBSD, but not on a daily basis, but on a, let's say, monthly, yearly basis, they see this big change and they try to integrate the patches they don't understand because they haven't read the commit message.
I actually think we should probably put a little subdirectory somewhere and put the Perl scripts or whatever it is that does the tips, or the awk scripts or whatever they are, set scripts, and a document that explains what they're for and how to use them.
Along with
and the
that
concept.
slide and a few others.
Do we have a precedent for something that changed quite as much code as this?
Do you remember KSE changed? KSE changed a lot.
That's not actually a good example. The reason it's not a good example is because it was actually several changes in one.
Well, right. And so that's why actually, if you listen to what I'm saying is we have a tolerance for one change, but what we'd like to not see is major renames and restructuring of the tree stretched out over a period of time, which is why I think there's a lot of benefit to investing time before the change to make sure that we're really not going to discover. 2 days later, it's fine to say, we should tweak that, fine, right? But a month later is a big problem.
If you look at the example you give, what you call the KSE change, was not actually the KSE change. What it was the process to thread change, and 95% of that change hasn't raised an eyebrow in the 5 years since it's been done. I mean, there were changes that were parts of that change, but they were to do with the threading library and so on. If you look at the actual change inside the kernel, where we changed from using processes for the basis of everything to the thread system being the basis of everything, that part of the change is pretty much exactly as it was. I mean, nothing has been changed.
Right. That was that change, right?
Yeah.
This is a different change, but it's the same class of change, right?
But I'm evaluating this. I'm equating this change to the process to thread change as opposed to the libc under R to the KSE part of that change.
But I do remember John Baldwin saying it's remarkably disruptive to his work to see lots and lots of renames going on in the tree. And my experience is that when lots and lots of renames happen in the tree, I have very similar problems. So, I think what we're looking for is some assurance that we're not going to see a lot of churn after this has happened. I don't think what I'm asking for has changed in 20 minutes or so. Right? I think we also have an obligation to give you a slightly hard time over renaming everything in the network stack, but that doesn't mean that it shouldn't happen.
I just happen to think that the time for this to come is when this latest set of changes that have gone in have been integrated together and we have the whole thing. We should start on this program that I've outlined here. And I'd like to see this happen relatively quickly. I don't want to start raising artificial barriers so that we're ready to go here and then someone raises another barrier and then someone raises another barrier and someone raises another barrier. I want to get to this point here with this stuff in, right? And have a little settling time and then be able to proceed rather than to hold it off, because every time we hold it off, more people are changing other things in the system and our patch keeps having to get reworked.
And to be fair, he's had it in a branch, he's got it running on a system, it's posted for review. I'm just saying, if you put too high a hurdle, this body of work's done every hurdle that we put in since S&P&G on what you want to see.
I have actually been following the work since the FreeBSD Foundation was involved in helping to fund the work.
I'm saying he actually did follow the back.
Right, but what this is being sold as, though, is a general purpose, a framework for general purpose virtualization.
Yes.
And what I'm still asking for is some assurance that we're not going to discover that we did it.
Well, we have several different points. It's not all just one module as it is. I mean, there's the IP version 6 code, and there's the IP version 4 code, and there's the divert sockets code, and there's all sorts of other bits and pieces. It's not like we've taken one kernel module and done it. We've done lots of different modules, or rather, it's done.
So I'd say that the part that is conceived like the top level virtualization framework, which should be general, is perhaps 1% of this change. Most of the substance is really network stack specific. So regardless whether we wish to completely abandon what we see here as a concept of generalizing access to virtualized resources, the scope of this change won't turn itself upside down. So the way we will
I have great
with
confidence.
networking, it will, I think, remain greatly the same.
Right. I have great confidence that lots of time has been spent thinking very hard about the implications of the network stack. I have absolutely no doubt of that because
I'm doing it again from learning.
Right, because I've watched that happen, right? The great attention has been spent to the network stack. And what I'm saying is, but if this is part of a larger framework for larger changes outside of the network stack, what about that? Great attention has not been spent there. And that's not a criticism of the virtual network stack work, right?
But it's not. I think, despite that he says that's true, I think it's not true. Because the whole concept of the way in which the virtualization is done with the per module stuff and the pointers and so on took a lot of thinking about how to make this general for not just the network stack, but for general purpose modules which are loaded and KLD loaded and KLD unloaded and so on. And that stuff is not dependent on the network code, and it isn't. The naming is in the VNET stuff is simply because it's network stuff. And if you were to be doing, there's nothing in the naming, for example, that's going to require that to be changed in the network code. So if you've got great differences in the network code, the diffs in the network code that you want to play against, there's no way that the VNET stuff in the network is going to be called something else unless you want to call it vRobot. I mean, yeah.
I've thought about it, but I just can't convince myself it's the right thing to do. But let me ask a slightly different question. Suppose I were to sit down this evening and want to spend some time with the POSIX semaphore code.
Yes.
And we have the hacking session this evening.
And
do you have a?
We could walk you through it.
Right. So
the document that was applied, that was asked for, who asked for it? Somebody else.
Right.
Yeah, Andre. I will admit that document is not written as a document at this time.
Right.
And
Sure.
that has to be done.
But suppose we were to sit down in the hacking lounge tonight and try to go through the POSIX semaphore code. Do we have a reasonable chance of getting through a moderate number of the structural changes that are required? Not necessarily get it working, but to sort of walk through the steps and do that in an evening or two. Is that
My
feasible?
guess is you could probably do the whole damn thing in an evening.
Well, you mentioned load averages took a little longer than that. But the number 3 weeks was thrown around. Yeah. So, okay. Well, maybe what we should do then is go through that exercise this evening and see what we can do with the POSIX semaphore code and see how it plays out.
Sure, sounds fine to me.
Right. And I'm willing to sit there and hack the code to do it. So.
Too bad the TRB is.
yesterday we had some unresolved issues, for example, around UMA zones, whether to have separate ones or to merge them, have the same one, resource allocation
I think
issues.
this is a question which is actually more a policy question than a technical question. It's a question of how do we want the thing to behave? It changes the way it behaves, but it's not a, if you do multiple zones and you have resource limits per zone, if you have single zone and you have resource limits per system, and really it's not a technical question for us to answer. It's a per module. Whoever's virtualizing that module needs to decide how they want that to behave in that module.
Sure, but it's sort of a big picture question or a big picture policy thing. So what I'm missing a little bit right now is also how this fits with jail and different virtualization ideas. So there's virtualization for like the jail-like stuff, where you want to give some sort of customers or so a certain amount of freedom in there.
Some
autonomy, but on the other hand, you want to restrict them by not having them to change IP addresses and stuff like that, and also to isolate their behavior in CPU usage, network usage, this kind of stuff from the whole system. And then on the other hand, you have got the network guys who want to run 20 instances to test their routing protocols and to have these different stacks talk together and to simulate a mesh network, whatever, this kind of stuff. So these are very different use cases.
Yes, and we're in the discussion we had with David just before just after lunch. It came to the thought that he brought up a good point, which is that for branding purposes, FreeBSD jails are a well-known thing, and everyone knows about FreeBSD jails. Of course, it might make it hard to explain to them that jails have improved, but they know about FreeBSD jails, and it's an important branding thing. So whether we should call the things jails or not, but that's different from the technical question, which is that I don't think we're planning on removing the old jail behavior. So I think what we'll end up with is a jails with an option of doing type A or type B jails, or so we can still do the sort of the slight separation jails that we had at the moment versus the complete separation jails that you will have in the future. You'll be able to select one or the other.
And I think we also should have some sort of
maybe combined ABI.
That people
how much of a jail?
Actually, yeah.
Is it solitary component or not?
Yeah.
With the UMA thing, the memory types, other than MBUFs, are there memory types that tend to float between the virtual images?
I think it's no.
No.
Well, I guess IFNets are probably come out of the base images and then a load.
You assign an IFNet to a jail, and it goes there and it stays there.
But new ones are not allocated inside, or are they?
Well, you could be, yes, because you could create a new GIF interface inside your jail.
Or NG.
Right, so for things like, for the InPCB and so on, it seems fairly clear that those live inside a particular instance and they remain there. And you could imagine having separate zones. But I guess what I was trying to get a sense of is what kind of memory types really have to be global as opposed to per instance, because the memory will float between them and you can't tear down the zone that something's allocated for before it's freed.
Probably the IFNet structures are global, even though they're in different structures, simply because you can pick a jail up and put it in another, pick an IF interface up, put it in another one, and you don't want it to be allocated from one zone and then freed into another zone, which would be highly confusing.
Yeah, so I was just wondering if there were any other types you know of that have that property.
I can't think of any. I mean, everything else is sort of once it's in the jail, it's there.
PCBs must stay with the same instance. So
and firewall rules and stuff.
We cannot move an open socket from another. So
but M tags, for example, would float between them because they're basically MBUFs.
Those are attached to MBUFs.
Those are the tags that hang off the end.
But actually, are tags allocated from zone?
They're allocated from malloc, and malloc allocates from zones. But malloc types are very similar to zones conceptually. Yes. Yeah. Well, it's a global malloc type.
I think that to be bigger picture, could we find a way of, and the marketing picture, can we find a way of saying this is a jail, and
This is a jail on steroids.
Set properties, set a profile on the jail. This is a normal jail as it behaves now, and then add virtual networking to this jail. Set jail profile, or then
Classic jail. I guess, yeah.
A classic jail, a jail
Classic
with
jail,
nice
classic,
windows,
yeah.
a jail.
Legacy jail.
It sounds like a museum. Isn't that what jails usually become?
that or hotels. That's also popular. Another general architectural question, something that Marko and I talked a little bit but didn't really get to expand on was this code exercise is something that we've never really done very well in the network stack, which is shutting things down. So historically we've been pretty good at starting things up in the right order, and shutting down was kind of, oops, the power got turned off, which is good and nice. But we now have to address that. I was wondering if you could just speak philosophically, generally, a little to how that was addressed and what you ran into. Inevitably, there were problems.
So ordering of the cleanup has to definitely be done in different ordering close to.
This is where having the init routine is actually good, because you get to see what it is you're
doing. Right. Well,
So
I feel very good about our startup. That seems fine.
Yeah. So it's recorded and it's basically attempted to be.
So we have a shutdown routine for each one.
Cleaned up in a different order. So the issue might be deciding on whether you are actually allowed to start the cleanup procedure. So whether you have sockets open or not. So at this moment, this is not particularly well handled. So probably running VNET should be marked as ready to depart, and then to avoid additional locking, so that no further processing sockets, anything should be allowed in there. So this part definitely needs more work, and
I will add that remember, for a compatibility case, when you've got only one VNet and you're shutting it down, that's basically reversible.
I was going to say, I hope that dies as horribly as it does currently in the new world order.
But if you're creating VNets, you're probably doing them as root or the system administrator.
Right.
etc.
Well, I'm more interested in the case of...
The difficulty here is that in FreeBSD4 it was basically easy. We could freeze the kernel and then be sure that when the cleanup procedure is about to start, that we can get no packets in, we can get no new sockets. So what I didn't want to load here is put in more locking for this part of the procedure.
Didn't want to slow down everything just so you could shut it down.
Right, yeah, but we do envision a world where VNets are getting released. I guess, I don't think this needs to be a solved problem right now, but I was actually kind of interested in what you ran into, in the sense that we will have to address this. So whether we have a hint at this point of what direction that's going to go in, and whether in the long run it's going to require significant further structural changes to the stack. Again, not bad, but I kind of want to see the direction.
Definitely things like, for example, in the route.c, for example, it has grown the detach. I think it's
destroy something.
It's a shutdown routine has grown in that function, in that file, so that when you shut it down, you free up all the routing infrastructure which you have created, and you know what it is you had created, because previously they were just static variables, but now there's an actual init routine that tells you what exactly it was that you initialized and what you got. So you basically take your init routine, you sort it in reverse, and do it, and that's pretty much what you've done. So
to add to this problem space, actually when you attempt to allocate a new VNet, the problem is that the original code assumes that at the system's initialization it will always succeed. So all memory allocations, everything will always just succeed. So
yeah, there's a lot of if equals null, panic, or better yet, dereference it and see if you panic.
So what can happen now is that we cannot know upfront whether there will be enough resources of all kinds for the initialization of all modules to succeed. So at this moment I have no clue. So I think I use some brute force hack, which is really nothing new like a solution. So to allocate insane amount of memory and then competence.
Yeah, but in some ways it's gotten a little easier because at least all the global data structures are allocated, you know, all at once together in these structures and things. But
well, but still, I mean, if we are allocating a separate zone per module per virtual stack instance, then the pressure memory is well.
I think we'll never be able to handle an allocation failure in that kind of case, because if we think shutting down a fully initialized stack is hard, shutting down a partially initialized stack successfully is going to be even worse. And so I think fundamentally there does need to be an assumption of a lack of failures during that allocation process, which means that we need to kind of replicate the system boot process, run it in a context where it is okay to sleep, and go through and make sure that all these places where we do these allocations, we aren't sort of conveniently holding locks at the wrong moment and so on.
Actually, it's not okay to sleep because we are. If we go to that path to start allocating a new VNET, then probably we will have acquired some lock on all the VNETs, and then sleeping in the middle of that process.
Well, I think you can have a big sleep lock, and you can have a thread which is the VNET starter thread, and you start up only one VNET at a time, and you do it while holding the big exclusive sleep lock that says, please do not tear down or start up any other VNETs at the same time, and all that, right? But
okay.
I think we have to maintain the existing assumptions.
Definitely.
Otherwise, it will die hard.
I think getting the initialization always right is much more difficult than cleaning it, destroying it now. Okay.
So what happens if you unload a really busy VNET right now?
You cannot unload it if it's busy. That's the presumption. So you should.
So all the processes exit, and
all the sockets should be closed, and all the TCP and all the state that is hanging off some timers should be cleaned up. So either we should wait or forcibly clean up those timers that make no sense anymore.
Yeah.
And well, only when those steps are done, then with certain amount of safety, we should be able to clean the rest of the day. Okay.
And do we have any way to tell when we've reached that point of safety currently?
All memory is free.
Well, no, but memory. Some of the memory won't free itself until you start to shut things down, right? Because you have all these reference cycles and so on. At some point, you reach a steady state where you're not injecting new packets in, and all the timers are stopped.
One thing to point out is at this stage, you can pretty much guarantee that the first VNET will succeed.
Yes.
Right? And you probably don't want to shut it down without reverting.
Right. Well, the first VNET, I'm fine with that staying forever.
So remember that what we're putting in now is sort of not going to destroy the behavior of the current systems. What we have to do now is all of the dangers and things we have to define and to work with are an extension to the current system. And so the requirements of what we do are slightly different regarding the current system.
I have something of a conflict of interest. I am a strong advocate for this work, and I think it's really interesting, and I think we need to get it in FreeBSD. And at the same time, I'm also a strong advocate for making sure that the things we do in our network stack are the right things to do, and that architecturally we're doing things that make sense. And so I have to make sure I approach this from both sides. So I apologize, I'm coming across as very direct and forceful and hopefully not too rude. But that does worry me a little that a fundamental question like how do you stop a VNET or how do you start a VNET is actually not quite answered yet, and yet we're going to make all of the supporting infrastructural changes to the kernel.
It's not that
I realize that chicken and egg.
With jails, you have the same.
Yeah, we get these jails that hang around for a while because TCP connections don't exit, right?
Which are much simpler entities than those guys.
It's not that there's no work that's been put into it.
Oh, right. I'm more asking about
it. No thought has been put into answering this. It's that it's a work in progress, and I think it's the jails NG have reached the stage now where to get much more further progress, we need to get it out of one per force branch with two people looking at it and another two people giving sidelines on the side, comments on the sidelines, to a broader audience. And if we wait much longer, we're going to miss the 8.0 window, which means 9.0. We really have to get...
We tried that last time, right? So that worked really well. Yeah. Right, for VNETs in 4.
Yes. So it's got to, I think the time it's got to go in is now. This is the window. We've got to get it in now at the beginning of this, early enough in the 8.0 cycle that we have some slack. But if things do go wrong, if we do all the best that we can do and we discover that we really have to redesign some part of it or change something, we've got the time to do that and test the new stuff. You know, we can't put it in 2 months before 8.0. It's got to go in. As far as it's got to go in now. Is my comment, because we don't have infinite time.
Okay, my question is not. I think that Robert is very right that shutting down things is really tricky because, for example, as Marko said, when the VNET is busy, you cannot shut it down, right? But you have to ask all the modules to shut down its own things, right?
Yes.
The allocated structures. And what do you do when, for example, you ask Firewall to shut down? You ask, I don't know.
So for Firewall,
a few modules will shut down successfully, but some other will
no. So, okay, I think you asked 2 questions. I mean, at any point in time, you can KLD unload your IPFW, and the same applies if you have a single set of state as you have now, or 100 sets of state. Okay. Nothing has changed here. So if you can KLD unload IPFW now on a running system, you should be able to do the same on virtual. No, there's no difference.
So you can end up with VNET which has no IPv4 anymore?
No, the key is not to start the cleanup procedure unless you're confident that this particular VNET is well prepared for this. So
how do you decide
yeah, right now we don't have an entry point right now in the network stack like the one that we've been talking about and have gradually been thinking about adding to the device driver stack, which is quiesce, right? Which says this network stack is going to be shut down. I'm not going to rip the ground under from you right now, but now would be a good time to start freeing memory, canceling timers, and stopping all your events from initializing, and draining timeouts and stuff like that.
And explicitly disallow any new state.
Yeah. Please stop injecting packets into the stack. It would be a bad idea to do so from now on.
I would put it to you that this is a good goal, but I don't think that it's a requirement to get this designed and in every single module in the system before we put this stuff in.
I think the obvious first step of any shutdown is there are no processes.
Oh, sure.
Yeah.
But it's not enough.
But that's not because all the time they're going to fire.
It's obviously
and
not enough.
go.
But there's no point in doing anything until that's true.
Yeah. So I'm doing that check now, but it's not enough.
So much more than.
Oh, there's much more than that. But that's the obvious first step. I mean, there's no point in trying to shut down while there are processes.
There's already code in the Vimage stuff that does that check and other checks.
So it's not enough.
And yeah, he admits there's not enough. But I'd like to say that remember we're talking about failures in a new feature, right? As opposed to failures in a feature which are in production use everywhere.
Right.
But on the other hand, you have to be careful that if you ship something in 8 and it has so many failure cases that it becomes unusable in the majority of cases, then it's only going to reflect negatively on FreeBSD.
The later it is that we put this in, the more failure cases there are going to be.
So
and the earlier we put it in, the less there are going to be.
Talking about putting this in earlier, assume there will be a release of 8.0 in 12 months. Put a schedule to this. And tell me for how long the tree would be unusable for developers. There's a 4-dot plan. You have 2 on your
on your board, and there's a couple more that are not written there. Do you want to put a time to that?
Okay, sure.
It can be wrong, but it would be useful, I think.
Order of magnitude. These are order of magnitude.
Yes.
Numbers.
So
I think to do just putting in these macros is probably a couple of working days for a full day working days for someone who's really dab hand with set. Plus or minus. Plus the fact that we've already got diffs that, you know, to some extent it's a case of extracting these things out of the diffs that we've already got. You could say maybe a week of real time. If you sat down for a week and did nothing else, you could probably.
And ideally,
get all that done.
the rest of us kind of lay off committing to the network stack for that week, so that the work is
the week is to generate.
The week is to generate the diff in per force.
And to prove the script does what you want it to do.
Right, but
So
remember if
sorry.
What's
the question
So
you asked
when will it hit the tree? From
Right.
now on, if you start working now, because that's what you're going to do.
I would say probably sometime the second half of June.
Okay.
It's the middle of May now.
Yeah.
So I'd say a month from now, we would have something to do
Mid-June,
the first
step one.
part of this. And that should, yeah, something like that. I would point out that I might be busy around the 8th of July when we have, my wife is now 7.5 months pregnant.
Yeah,
you should
two
sponsor the comic bit for.
The existing ones worked out pretty well, I approve.
You said
So second, the Structify and the image routines.
So the Structify, after we've got the stuff in, really the Structify would be taking a bunch of existing stuffs from the diffs, right, and applying them, which I think will probably be a similar sort of time, you know, 2 weeks to generate another diff. Like July 1st, something like that. Well, it might be done. They might be done in parallel, but I'm just saying, assuming that we do one and then we do the other. I could imagine structifying that, and then at that stage, I'd probably let it sit for a while, and we, you know, let people run on it. Check that people don't have problems with the init routines, because this includes, you know, adding the init routines and so on. They're written, but they're, you know, we would have to extract them out.
Okay, so. At the beginning you said at this point we could start performance testing, basically evaluating if the indirection will hurt us or not.
No, we don't have any indirection.
No, but you make your baseline. So after that, you're saying you make your baseline, right?
So we're structified, and we know we can compare, to some extent we can compare the structured version and the unstructured version for that. And I think we'll find no difference really. Unless it's
Are you sure? How can you say that?
Because he's already done it.
Yeah, but he said he's done some basic loopback tests yesterday.
Are you angry?
Well, in real life tests, I mean, you really are more hit by the
I know.
bus,
But
PCI bus.
people have spent more than a year to get the performance work in 7. or basic 8, what's in current now.
This is just simply a global structure. So you're saying dereference taking a global address of a structure.
Yes.
And offsetting it,
And it's
which is going to
affecting
be
the
ultra
entire
slow.
kernel.
It is true you are rearranging the memory of everything in the network
However,
stack. But
the example of what
I'd
we've
like
seen
to
is
think
that it
that
actually improves the memory, the cache coherency.
Well, I think that's
actually
noise.
has spent things up in the
I
past.
think that's noise too.
I think that's random cache line rearrangement, and that's a fine answer. That's a fine answer. So assume that this goes well,
Within the
and then
noise,
keep.
it's within the noise. The
Well,
differences, plus or minus, are within the noise, and it's not really. It's not going to produce anything in the way of performance. The differences which are meaningful, because you're going to get more of a difference by a single smart moving of a semaphore or something than you are from this.
Right. Well, you are tightly packing a lot of structures that weren't previously tightly packed potentially. So, but okay. So to pretend, we'll say that goes well.
Yeah.
Right. Okay. Let's move on to the rest of the schedule. Because I presume we have to escape to
So
dinner.
we probably should let that sit for a while at this point. And so I'm saying that probably the beginning of August, or maybe even, I'd say beginning of August is probably a good time to look at the next version, next step, which is to actually start applying the fact that that it makes an indirection instead of being just a global move to a structure.
That's what we think.
So there would be a performance. This is where the performance, where you will probably get a very probably still in the noise, but where you can probably say it's already been moved into a structure, so the advantage of having any memory artifact structures.
That's what we are testing at the moment.
Probably
Yes.
So we add the indirection around August the 1st. So, and so what was the last step?
Add one module at a time.
Profit.
Yes.
Profit money.
That's right.
IPO.
Retire.
No, don't retire. Don't retire.
Work for yourself.
So you've added indirection at this point.
Otherwise we get stuck with
The ability, now at this point we add the ability to have more than one
macros, yes.
basically.
I've got one question there.
Multiply. Be fruitful.
What happens if, for example, like FW is not converted?
It is.
How will it? No, it's just an assumption. Yeah. How will it behave? Will it only be available on the host and not in any image?
Well, no. Functions which are completely global are shared.
Right. When you call the dummy net hook, assuming that dummy net weren't virtualized, you would get one dummy net across all of them.
Yes.
But when you re-injected into IP Firewall, you'd re-inject in the first step.
There would be problems. There would be problems in this. But remember that in the average system, for where all the people will be doing the work, there is only one. Right? There's only one virtual system for everybody except for the 4 people who are working on it. Right? And those people are adventurous enough, and we hope that they come to it.
So let's go back to the schedule again. So what happens next?
More than one.
Okay, when does it?
Indirection, probably right here. A couple of weeks after that, after indirection, we've still only got one of them, right? So we're looking like the middle of August, being able to turn on more than one of them. Now, there are going to be problems when that happens that for those people who are brave enough to try it. But that's okay, that's because they're brave enough to try it. For sure. No one's going to say this is going to be perfect. But what we do think is going to be true is that for those people who are only running one instance, there are not going to be problems.
I think the August 15th might be a little optimistic because August 1 was not adding.
When we add indirection, basically we are already there preparing multiple instances. So we will already
the work from here to here is incremental. There's a much bigger jump from there to there than there is from here to here.
Except for the performance measure.
I hear performance all the time.
Who's interested in that?
And there may be a misconception. This may actually end up being faster if you put the indirection in a local variable, because then the compiler doesn't have to reload, even if it is a global variable, after every function call, because the compiler knows it's sort of constant for that function. So whatever the concern about performance and cache lines, I don't see it. It may be a performance improvement.
And once it's in the tree, it gives something to try some other ideas that we talked about earlier, offline, to deal with some of that.
So I just think by middle of August, we'll have something that people can experiment with, and then we have at this time we have most of it, a large portion of a year before the 8.0 release.
No, you have 6 months.
When to code the slush? That's the real question.
Yeah, 6 months.
So that would be December 31st, January 1st?
Maybe. There is no date yet, but roughly. I said 12 months from now this is the release.
I mean, in my mind, the code slush for 8.0 realistic is probably March next year, with another 3 months to get it out, which would mean that we'd have like 10 months or so. 10 months to get the niggling codes out of it.
So between June 13th and July 5th, say allow July 4th for a holiday. People who are working in branches with large patch sets against the network stack should not plan on merging things to the main CVS repository. Is that right? Because that will invalidate the structure file.
It would be really cool if, say, the week before June the 15th, we didn't have to regenerate it 3 times a day.
Right. So on either side of those, could you put essentially a window of non-committability for large parts of the network stack? And by that I mean like the TCP internet.
So you should actually be fine before July 1st, because you can run the script on your diff, and any change you've got, we may have to make a second script that's smarter. One of those for pluses.
Right, but I'm worried actually about your guys' changes, right? Because between the 15th of June and July 1st, if I come along and I restructure in PCB info in order to provide connection groups, changing all the global variables and the layouts of lots of global variables in the TCP code, that would probably actually be a minor impediment to your making forward progress. So you would probably prefer I didn't do that change between the 15th and the 1st. Is that right?
It would be nice if yeah. I mean, from the size of the diff, the biggest diff is going to be this much.
No. You talk about his impact on you guys.
I'm trying to suppose I didn't want to shoot you in the feet.
That's the size of the work, the likelihood that we're going to get clobbered by it, right?
Right.
And how much work it is to fix the mismatch. Because what happens is you get a collision and you have to go through and you have to edit everything and fix it all. And the bigger you do this, the more you have to do.
I'm familiar with the wrong side of that.
It's the biggest target. This is the barn, the side of the barn. You know, anything's going to hit this.
Right. So starting June 7th.
This one's going to be probably, most code changes are not going to hit this. Most code changes are down in the functions within programs and or in files, rather than up at the top of it where this stuff is largely. And so that's a smaller target for other people to hit. But still, it's there. The indirection. That's
at that point
at that point the main diff to the rest of the tree is gone.
Right.
Okay?
So between
We're
June
working
7th.
our own macros.
So between June 7th and July 7th. So basically a month there, you would prefer other major track changes not merge in if they're going to affect big piles of global variables and zones and stuff like that.
If you make changes, that doesn't mean you can't make changes. You might want to contact us and say, this is what I'm planning on doing. This is what the logic of it is.
Right, but if I make changes and they do interfere with you, it could push your schedule back by a week or something potentially.
Well, it depends what you do. Yeah. I would hate to. That's why I wanted, for instance, to get my multi-role routing table stuff in earlier, so that I wouldn't have these two things hitting each other, because I've spent 4 days cleaning up already.
Right. So I'm on vacation from June 3rd until about June 18th. So that seems okay.
But to be fair, actually,
take an extra month off.
For the June 15th commit, these guys need to know is what are the names of any new global variables, because that said script should be run on a freshly checked out tree, lock the tree for 2 hours, run the set script, build world, boot it, check it in, right? The script should be mechanical, right? That's what we kind of agreed to. That stuff's very mechanical. So he just needs to know ahead of time that the day before he's going to run the script, you added the foo global variable and it needs to get added.
What we want to do is to be able to produce another branch in Perforce, which we can automatically create. And when we do a difference between that branch and our branch, all of the V under macros disappear out of the diff because it's done the same thing. I can imagine that there are going to be some manual touch-ups here and there. But we want to get the bulk of this done so that the average third-party company can do the bulk of their work the same way.
So then after August 15th, at that point it becomes a question of hitting individual subsystems as they become virtualized.
Yes.
Do you have thoughts on when in this process an administration interface would be designed and implemented? It's fine for you to say September. Just say whatever you want, but I was just wondering what you're thinking.
A few months down the track, we've got a very crude interface that Marko's been using. It's pretty much the same one you had in 4.0, right? It's a pretty crude interface. and we'll try and that'll be available. But actually, one thing is that hopefully other people who know more about it, maybe the Vario guys, maybe you guys have.
Love to.
Maybe you guys have ideas.
We were just mumbling about that back here while
Because
you were.
you've probably got an API that you have been using for your stuff, which is designed for real users.
Yeah.
Which we're not.
And the talk we had yesterday about a string passing sort of interface, we're certainly working well with this. So I'd like to come up with some kind of standardized interface for this, something flexible.
We need to generalize some stuff.
Yeah.
By the way, there's 25 minutes till we're supposed to be at dinner, just to let you all know.
Oh, we've got 25 minutes.
Let's get out of here.
Right. So, but let's plan on meeting up in the hacking lounge tonight and seeing what we can do.
Where's this happening?
Come to the third floor of the residence hall.
Okay,
Same place. You can find that. And
okay, I'll have to do that.
Hey, could you move to the left, please? Yeah, all right. Thanks.
So talk for an hour and 20 minutes.